Hello. Ladies and gentlemen, a very good morning and welcome to day 2 of the Human Capital Working Group AI Summit. We now begin the technical session 1 titled The Architecture of the National Language Transition Mission. This session will discuss the technological foundations of India's national efforts to build inclusive language agnostic digital public infrastructure. It is my privilege to invite our distinguished speaker for this session, Professor Mitesh Kapra, Professor at IIT Madras and Head of AI for Bharat, a leading initiative driving research and deployment of Indian language AI systems at scale. Professor Kapra is joining us online.
Hi, everyone. Thank you for inviting me here. Thank you for this opportunity. So I'll be talking about the Indian language technology mission, right, and how it has been transforming the landscape of Indian language technology. Uh, so Bhashini was conceived or at least got started around 4 years back, and the goal was to build the foundation to enable machines to understand the rich and diverse lives of Indians, right? Which of course means a large part of this diversity comes from languages, right? So there was a lot of emphasis on rapidly accelerating the development of language technology or AI technology for Indian languages, right? And we at AI for Bharat were an important part of this journey where we were the data management unit, which means a large amount of the data that was collected and released as public good through Bhashini was collected by our teams. Right? And now, when this mission started, and like I'll just interchange between the journey of AI for Bharat and Bhashini, one simple question was that why is it that Indian language technology today is not par with English, right? And the simple no-brainer answer to that was that there are not enough data sets for Indian languages. Okay? That's one part of the problem. The other is when models are built, uh, the deep tech industry sort of sways between these two extremities. One extremity is profiteering, where English and certain politically important languages are given more importance, politically, commercially important languages. And this is the profiteering side, and the other is the positioning side or posturing side, where there is emphasis on, hey, we should be inclusive for 1,000 languages, 10,000 languages, and so on, right? And in both these extremities, Indian languages, and if we talk about the languages included in the eighth schedule of the Indian Constitution, which are 22 languages, lie somewhere in between, right? Because when you're looking at only the commercially rich languages, then these languages will not get attention. And similarly, when you're talking about 1,000 languages, 10,000 languages, you cannot zoom into a specific set of languages that you care about, right? So that's where we come in. We said that we'll focus on the 22 languages, which cover around 90 to 95% of the population of India, and make our modeling choices also accordingly, right? Another reason for Indian language technology to be behind is there is no incentive for people to build models for Indian languages because there are no good benchmarks, right? So if there are no benchmarks, no one can show you the mirror saying that, hey, these are benchmarks for, say, Marathi, Gujarati, Telugu, Hindi, and on these benchmarks, your models are not doing well, so you better improve, right? So that's why evaluation is also an important part of the journey, right? So the past 4 years, we have been building this ramp. It is intentionally structured as a ramp, as you see here, where the focus has been on building foundational data sets for Indian languages, then using these data sets, build multilingual models which cater to Indian languages, and then also design evaluation frameworks, which includes both benchmarks as well as relooking at evaluation metrics to ensure that they are in line with what is required for Indian languages, right? So, as a quick example, the blue metric, several studies have shown, which is used for machine translation, is not very uh, appropriate for Indian languages, which are morphologically rich, right? So all of these three foundations need to be addressed to ensure that Indian language technology progresses, right? And there are several verticals. Of course, a lot of this has happened the pre-LLM era. So now, of course, with the help of very large language models or the frontier models, Um, LLMs are now doing all of these as one single model, right? So it means speech recognition. If you interact with any of the foundational models from the frontier labs, then it would be able to do speech recognition. It would be able to do speech synthesis, machine translation, OCR or vision-based reasoning. All of that a single model does. But when we had envisioned this program, there was no LLMs at that time, or at least the current generation of LLMs were not there. There was a previous Gen Zero generation of LLMs, and hence we had thought of these as silos. That there should be speech recognition models, OCR models, machine translation models, speech synthesis models, and transliteration models, because there's a lot of demand for transliteration in the Indian context, right? So these were the verticals that we were focusing on. And while the emphasis was on foundational work on datasets, models, and evaluations, there was also an eye kept on deployments, because it was important to show that the technology that we are building is actually helping people on the ground, right? And as a part of this, there are a few deployments that were done with the help of our partners, both at Bhashini and Ekstep Foundation and others. I'll give you a couple of examples to just drive home the point that the technology is not being built for the sake of building it, but there is also an emphasis on ensuring that it reaches the last mile citizen, right? And so one couple of examples are, one is the PM Kisan bot, which has now morphed into something known as Vistar, where the idea is that a farmer will call a bot and ask some very basic questions, right? It's a very limited domain, and the farmer wants to know the price of certain crops in the mandi today, so that he can decide whether he should go to the mandi today to sell, or maybe hold on for 1 or 2 days when the price would hopefully be better. Or for a kisan to ask that there are some disease on the crops, then what can I do? Can I use a certain pesticide? If yes, where can I buy it at a subsidized price, right? So this entire bot is being powered by open source models built at AI for Bharat, speech recognition, speech synthesis, and even translation. And it works quite well. It is being used in Maharashtra, and right now efforts are on to scale it up, right? Similarly, there's assisted language learning, where the technology being built is being used to see if foundational literacy for students can be improved. So foundational literacy focuses on grade 2 to grade 5, where the idea is that a child should be reading at the right grade level, right? And there are several studies which show that in India, only 23% of students in grade 5 read at the level of grade 5, right? There is some lacking lacunae in their skill, and they are not reading at the appropriate level. So with the help of Step Foundation, we built a very simple tool where a student comes in and logs in the lab which is there in a government school. It just has a few computers. The student logs in and he or she sees a sentence on the screen. They can read it. As they are reading the sentence, in the background, a speech recognition model is running and detecting what the child has read. If what is read matches what is there on the screen, right, then that means the child is reading properly. Otherwise, you can build some sort of an understanding of where the child is lacking. For example, m and bh are getting confused, or p and f are getting confused, right? This is again being powered by speech recognition models, which are built as a part of this program, right? Now, what I'll do is I'll zoom in into one of these verticals and sort of give you a sense of what does it take to build such technology at national scale. So I will zoom into speech recognition first, right? So focusing on the first layer, which is the foundational datasets. So we had this nationwide data collection drive, which was uh, run by AI for Bharat, right? And our goal was to go to close to 500 districts in the country, which are where we find native speakers of the 22 languages that we were focusing on, right? And these include all the peninsula languages, Gujarati, Marathi, uh, Kannada, Malayalam, Tamil, and so on, and also languages in the northeast like Manipuri, Assamese, Santali, Bodo, Nepali, and so on, right? And from the north, Kashmiri, Hindi, Urdu, Punjabi, all of these languages, right? So we had set up ground networks where we used to go to our teams would go to every district and mobilize 100 to 150 participants and collect voice samples from them in a very structured format. So if you go to someone and say, hey, can you talk for 10 minutes with me? They'll just end up saying their name, their place of birth, what their family is, who all are the family members, what their occupation is, right? But we wanted, in such a case, you won't get vocabulary coverage, right? So we also wanted them to speak sentences which come from good downstream use cases, right? So can you book a gas cylinder, right? So imagine that you are calling someone to ask them to send the gas cylinder. So can you just say a few sentences which would enable that transaction? Or can you book a taxi for going from location A to B and then explain some directions to the taxi driver to how to reach your house? Say that there's a landmark here and this is the house number, it's near some tree and things like that. Right? So that would enhance a vocabulary coverage and also cater to downstream applications, right? So this entire data collection work was done ground up by building tools. We built on top of the open source Karya platform to collect data, voice samples. We also build a transcription tool where once the data is collected on the ground, we have in-house team who transcribes these audios. And our ground teams went to different places in the country. So you can see images here from Darbhanga in Bihar, Jammu in J&K, Jammu, and then Srinagar, and then Imphal in Manipur, right? And through this process, this number is now outdated. We are twice this number now. We have been able to collect around 20,000 hours of data for 400 plus districts, right? And all of this data has been released in the open source. As and when chunks of data get collected, we put them out. So all of these milestones that you see here are different releases of this data as and when some portion of it was ready. And we are now close to releasing the final version. By this month end, we should have it on AI Kosh. Right? Yeah. So this is for the foundational work of sort of building data sets, right? But given that we being a technology organization, we are also interested in building models, right? And our goal there is to build models in the open source. But just because they're open source, they should not be on regret models. They should be no regret models, right? So no regret means that anyone should happily use them and not worry about the performance, that there's a commercial model available which is much better and I'm not able to, I'm just stuck with this open source model which is not so good, right? So I'll tell you about how we sort of always aspire to make sure that our models compete with the best and are comparable to the commercial models out there. Right? So here's a chart, and I'll spend some time on this chart. So on the x-axis, you see time. So 2022, and then last is 2024. On the y-axis, you see performance. Right? So the higher a bubble on the y-axis, the better is the performance. And if the bubble is below this red line here at the bottom, that means that language is not supported by the model. Right? And every bubble here corresponds to one of the 22 languages, and the size of the bubble is proportional to the speaking population of that language. Right? So you can see Hindi has the largest bubble, followed by Bengali, Telugu, and so on. Right? So in 2022, when the famous OpenAI Whisper model came out, it was supposed to be a multilingual model, but there were many Indian languages. You can see a large cluster of languages here below the red line, which were not supported by this model. And even the mainstream languages like Hindi, Tamil, Marathi, Kannada, Urdu, which were supported, their performance was not up to the mark, right? You can see that they were, you clearly need to be at the top side above this 20% line here, which is the error rate. So you want the error to be less than 20%. So it has to be above this. But none of these languages had a good performance. In 2022, just about the time when we had started our work, we released the first model which was not only supported more languages. So now you can see that the number of languages below this red line have reduced. That means more languages were supported. And not just that, the languages which were supported, their performance was also better than the Whisper model. Right? And then in 2024, we had another model where we made sure that based on the data collection effort that I spoke about in the previous slide, where we covered all the 22 languages, we were now able to support all of them, and none of the languages were left behind, and all of the languages also moved up as compared to what we had in 2022. And while we were doing this, of course, there are models from other deep tech companies that we track. So there is Meta, there is Microsoft, there is Google, and we make sure that we always stay in the same zone as these models, right? Of course, these numbers are averaged over benchmarks. So it's possible there's some benchmark where Google is better than our model and vice versa, or for some language, right? But on average, we are always trying to stay in that comparable competitive zone, right? So that's what we do with models. And today these models are used quite a bit in the Bangalore startup ecosystem for building various voice-based products for Indian languages. I have seen a few. One I spoke about is the farmer bot. I've also seen a product where people are using it for conducting interviews, right? So this is to train people to speak more confidently. And the whole sort of idea there is that you could have this voice recognition model which can understand whether the speaker is speaking correctly in English or making pronunciation errors or any other language for that matter, right? So that in applications like these, our models are getting used. Yeah, and these are the different models that we have released over the years. Now, in hopefully by the end of this month, we'll have the next generation of our models, which would have an LLM backbone, right? So as I had said, when we started off, we only had planned these verticals as independent verticals and not thought of them as a single model supporting all of these tasks, right? But now we are moving to a single model, like an LLM based backbone, a sovereign LLM which will power all of these tasks, speech recognition, OCR, etc. So we are hoping that we should release a model by the end of this month or early next month. Then I spoke about evaluations. So again, in evaluations, it's important that evaluation benchmarks are mindful of how things will get used in India, right? So for example, there is no point in having a benchmark where people are just reading sentences from a textbook, right? That's not the real use case. The real use case is when someone is trying to place an order for a gas cylinder or trying to place an order on Big Basket or trying to make a transaction on UPI, and that sentence has to be recognized perfectly so that all the entities are clearly identified, right? So the benchmarks that we create for evaluating speech recognition models need to be aware of these tasks. So before our work, the like one of the popular benchmarks was the Fluor's benchmark, which just has read sentences, right? And these sentences also don't come from an Indian context. They are sentences which have been translated from English content, right? So they are not very representative of the use cases or the scenarios that we care about, right? Similarly, demographics, it's important that all age groups are covered. So we have made sure that in our data as well as benchmarks, four different age groups are covered, 18 to 30, 30 to 45, 45 to 60, and 60 plus. All districts, as I said, around close to 500 districts are covered. Then different education backgrounds, because that might influence the vocabulary that they use, the accents that they have been covered in the benchmark. And blue collar, white collar jobs, people from different backgrounds, all of it has been covered. They also have different domains. So we asked people to speak about entertainment, legal domain, sports, banking, and all of that. So all of this is covered. And different styles also, like a monologue extempore style versus a two-party conversation versus red speech. All of this is sort of covered in the benchmark, right? So this kind of a benchmark was missing earlier, where you could holistically evaluate models on Indian languages. And as I said, if there is no benchmark, there's no incentive for anyone to build technology for that language, right? So it's important to create these benchmarks. Yeah. So now moving on, like this was the sort of and the milestones that you see here. These are all the different benchmarks that we have released over the years. Some of them are accent specific. So, for example, Swara and Lahaja are benchmarks for English and Hindi respectively, where the conversations or the spoken content comes from people all over the country, right? So it's like an Assamese speaking Hindi, Assamese native, someone who has a native language as Assamese but also speaks Hindi, right, for various reasons. So we have sort of conversations from them, and their Hindi would have a certain accent, which may not be mainstream, and hence the performance may be poor, but we want our models to work better for them. And that cannot happen unless you benchmark it, right? So we have created benchmarks where such characteristics are also captured. So this was the journey for one task, speech recognition, datasets, models, and evaluations. Now there's a similar journey for other tasks, machine translation being one. So now I'll slightly rush through these. I'll not spend as much time in detail on these. So here again, our goal was to create a very large scale corpus of parallel sentences between Indian languages. And we had a very large in-house team of close to 200 translators who represented all the 22 languages and 14 different scripts. Right? These 22 languages, many of them have their own scripts. Of course, many languages, close to 9 languages, I think, use the Devanagari script, but many other languages have their own scripts. So we had translators, we had a tool developed which had a maker, checker, super checker workflow to ensure high quality. We also did large scale mining of the data. Uh, to get parallel pairs from the internet, right? So while manual data collection is expensive, it's also of high quality, but it can only be, it's not very scalable, right? Because it's costly and you cannot find so many translators who can do it at a certain quality. So we need to supplement it with data mined from the internet. I'll not talk in detail about it, but there are methods by which you could uh, you take a collection of all the Hindi sentences on the internet, take a collection of all the English sentences in the internet, and just by accident there would be a sentence in this collection which is a translation of the sentence in the other collection. And the reason that would happen is, imagine news articles, right? So there would be a news article of say a political leader visiting some state to give a speech, and that article is likely to be published in multiple languages, and hence there would be translations just by accident in this large corpus. So the idea is to get these translations which are just lying there by accident, right? So we are able to create a very large scale corpus using that. This is again released publicly. It's available on AI Kosh. Similarly, models, the same story. We compare with the best and we try to stay at the top of the curve. So today our models are quite competitive for translation, and they're again very widely used in the startup ecosystem. Similarly, we created benchmarks, which are India centric. So again, here the benchmarks were typically Western centric. So that what that would mean is that there would be a sentence in English, which is grounded in the Western context, and then somebody will have translated it to Hindi, and then a machine translation system is being evaluated to see whether its translation matches that ground truth, right? But then, given that all the content was originating in the Western context, you wouldn't find a sentence on, say, the Battle of Plassey, right? Or you wouldn't find a sentence on, say, the First War of Independence, or you wouldn't find a sentence on Bharatnatyam or any of the music forms, right? Hindustani, Carnatic, and so on. So we made sure that such sentences are actually included in the benchmark so that we can evaluate these systems in contexts which are relevant for India. Similarly, we had work in speech synthesis where we have set up studios in our lab where a professional voice artist, so this is a portable studio that you see here. It has all the necessary recording equipment in it, state-of-the-art equipment, and we call voice artists who then come and give us their voice samples. So this voice would then become like the voice of that language, like just as you have Siri voices, you would have a voice for each of the 22 languages. So we are close to finishing this data collection for all the 44 speakers. So for every language, we wanted one male and one speaker, and we are close to finishing that. Similarly, we are now working on optical character recognition, where the goal is to again create data sets, models, evaluation frameworks for OCR for Indian languages. So you can see a very complex layout here. It's a newspaper and it has multiple paragraphs, section headers, bullet points, tables, pictures, captions, everything that you can imagine, right? And at the bottom, you see all of those labels which are there in this page, right? And you're trying to create annotated data so that models can then learn to isolate these areas and then do the character recognition within these, right? So what next, right? I'll just take 2 more minutes. So while we have been laying down this foundation, and because our models are also getting deployed in end use cases, we end up getting a lot of feedback from end users, and we are now trying to address that, right? So one of the things is that none of the data collection focuses on child voices. So if that is the case, often in educational use cases, now today everyone wants to build a bot for tutor bot for children, but it won't work very well because children's voices have a very different spectrum, and hence models trained on adult voices often don't work, right? And I see that regularly with my own kids. Their voice is not recognized well by models, right? So we need to make sure that our models work better for children so that they are applicable in the education domain. We also need to make sure that our models work well for rural women. They are often excluded from data collection because of societal constraints in India. They often don't participate in data collection. So, can we do something so that the models work well for them? And this is very important from the mandate of ensuring digital inclusion for women, especially in the finance sector, where they should be able to make calls and do financial transactions, given they won't have smartphones and mobile literacy, right? Um, can we make it work on telephony, right? So a lot of speech recognition use cases in India are on telephony. Everyone wants to automate a call center, but call centers in India run on the telephony line, which is an 8 kilohertz channel as opposed to 16 kilohertz or higher, right? 16 kilohertz is where most of the data gets collected. It's very hard to collect real call center data due to privacy issues. So how do we make sure our models work better for that? Right? And then can the translations be made more colloquial? So right now, a lot of models, including ours, produce very formal translations. For example, my favorite example is that परीक्षा केंद्र पे आपका पहचान पत्र आपके पहचान पत्र की जांच की जाएगी. No one in India speaks like that. It would be exam hall पे आपका ID card check किया जाएगा, right? So this is very colloquial code mixed translation, which everyone understands, right? Now imagine you have a bot in which some translation is being produced, and this is the information given to the user. The user has asked about what will happen at the exam center, and in Hindi, and the bot responds saying that परीक्षा केंद्र पे आपके पहचान पत्र की जांच की जाएगी. It will not be very easy for the person to sort of grab that information, right? So it's important. Then can we translate spoken text to make sure that educational content in in English, which is predominantly in English, Khan Academy, other sources, can it become available for Indian languages, right? And can we have an audio LM for Indian languages and so on, right? So this is what we plan to focus on in the phase two. This and many more things. We're also working on the foundational sovereign model for Indian languages. Hopefully, we should have some updates in the coming months on that too. So I'll take a pause here. I'm just about at the end of my time. So yeah, I will be happy to take any comments or questions. Hello.
Thank you, sir.
Yeah.
I now invite Professor Rohit Sinha, Dean Research and Development, IIT Guwahati, who will share institutional and research perspectives on building and integrating language technologies. Okay. I'm so sorry. Professor Mitesh Kapra is going to have the question and answer session now.
Anyone has any question? Good morning, sir. Am I audible?
Yes.
I'm Nishanjoti Haloi, a student of North Guwahati College. Uh, as much as I'm aware, large models like ChatGPT and Grok, etc., needs a lot of data to be trained for. And
Right.
where is this all this data coming from that these tech giants use to train the AIs? And if it is the data that is available in the internet, then I think that belongs to individuals like us, which we have never given consent to use. So where do these tech giants gets all the data to train the AIs?
That's not a question for me to answer. I mean, it's for the tech giants to answer. But yeah, I mean, it's reasonable to assume that a lot of that data comes from the internet, right? And I'm sure there are measures taken to ensure that uh, personal data is excluded to the extent, but I don't know how much that is really practically feasible. But as I said, it's not a question for me to answer. Maybe, yeah, I could just say that yeah, everything on the internet is considered fair game for training as far as my understanding goes, and I'm not fully aware of how much due diligence is there done there to ensure that people get credit for the data that they have. Sorry, I'm sorry if my answer is not adequate for you.
Hello, sir. Good morning.
Good morning.
I'm Mohan Krishna from IIT Guwahati. Sir, I do my research on sign language translation.
Yeah.
So, what is the inclusion of this sign language translation along with this ASR, TTS, and from the perspective of AI for impact of India?
Yeah, so sign language, of course, is a very important area to work on, right? Because it affects a significant population in India, given this large size of us as a country. Uh, Currently, we are at least not working on sign language translation, and I'm not sure of any large-scale efforts on addressing that problem, right? We have dabbled a bit in it in the past, and it's also very challenging to work on because sign language standards are different across the world, and India has its own standard there. That's one challenge. The second challenge is that as you go towards languages, right, then there is further diversity. The way you would say the sign that you'd use for home in one language versus how do you say sentences in multiple languages, right? And also, given the general body movement, right? So now, if I try to do sign, you can see my screen, and my hands will often get sort of obscured, right? Because I'm constantly moving, and this camera only captures so much. So even for building for applications like Teams meetings and Zoom meetings and other things, it's very hard to keep these things on work well in practice. Right? So it's an important area, and I hope there is some large scale effort in addressing it. But currently, I'm not aware of any such efforts.
Okay, sir. Thank you.
Any other questions?
Morning, Professor.
Morning.
I'm the Principal Secretary from the Government of Assam, and we've been using the solution that you have made. And congratulations to the whole IITM team and all of you for having pulled off this very small model which works so well. My question
Thank
to
you.
you was, what is the future roadmap? See, because the translation quality is very good. But what happens in the government is when we start using it for the file notings and we start translating the office orders, people start saying it is not that good. I got to make changes. And
Yes.
that's where what I wonder now is, are we to wait for as IIT Madras and as you keep developing these models and all languages get better, are we supposed to wait for the tide raises all boats kind of a thing, or should we now fork out at some point, or what is the advice that you have for us where it is
Uh,
very good as a national agenda, fantastic job done, but if you want to reach that last mile, take it to the 99% kind of satisfaction level, what is your
yeah.
advice for us? Thank
Yeah.
you.
Yeah. Thank you, sir, for asking that. So yeah, I think the AI at its core is a very simple game, right? It's about data. The more data you have, the better your models would get, right? And I think one sort of request that I have, and I keep saying this in different forums, and I hope at some point it materializes, is that we need to invest in AI to ensure that data generation happens in a way that AI can take advantage of it, right? So right now, what happens is that in many use cases, people overestimate in the short run and underestimate in the long run. So what that means is that when I say that I have a translation model, people expect it to work at 100% accuracy immediately, right, in the short term itself, which is not the reality. And when they try it, it does not work. And then they underestimate in the long run. They say, okay, today it's giving me some 80% accuracy. There's no point in investing in this because in the next 5 years also it will remain that. But that's not how AI works, right? So for the first 2 years, if we are patient with this technology, and we keep using it and sort of giving feedback so that the technology can improve, then within 2 years we'll see a significant jump, right? That 80% can go beyond 95%, right? So in the specific use case that you spoke about, and if we can have a system for all government departments across the country, where any translation work happens through a single interface, which is powered by AI, right? And whatever edits, there will be a human in the loop required for the next 2 3 years foreseeable future, in my view, right? But the edits will become lesser and lesser over time. But whatever edits are being made, those are captured by the system and fed back to the AI, right? So you'll immediately see that every 6 months, the errors that you were fixing 6 months back are no longer being shown up as errors because the model has learned and improved, right? So this loop to compound, right, where the models get deployed, data from the usage comes back, the model improves further, and everyone benefits from it. That I have not seen happen anywhere in India in public deployments, and that needs to happen. And then the systems will improve collectively without us doing much, right? Because we are just doing the translation today. We are doing it manually with the help of AI. Maybe today 50% of the effort is going down, and over the next 3 years, slowly, slowly, that will become 75, 80% down, right? And that is just a natural journey because it's not extra work for anyone. Anyways, you are doing translation, so why not just do this to this common interface, right? So that mechanism needs to fall in place, and I'm happy to discuss further on how do we enable that. Yeah.
Commentary on this one. I'll thank you for that offer, and I will connect with you separately. But currently, I want to say that most of the translation that we're doing, we are now integrated with Bhashani, the Bhashani app within our e-office system. As you know,
Got it.
across India, we have this e-office system which
Yes,
does
yes,
all our of file work. But
yes.
the Bhashani team did not try to put any such mechanism to trap these the diffs between what comes
Ah,
out and what we update. They have not done that, nor have we
right.
got any instructions that we can share that. So maybe I can
Yes,
work offline with you to understand how we could have done that. But
yes.
you're saying in the current setting, the improvements are seen only when you release the next update. So just one last question. What is your roadmap of sorts? What is the frequency at which you plan to come up with updates, whichever way?
Yeah.
I'll talk
So
with
I
you
think
offline.
we have one update coming up in the next 1 month or so as a part of the India AI mission. And then we plan to have updates every 6 months. Hello?
Hello, sir. Myself, Chanmoni Kolita. I am from Gejananda Chaudhary University. So my question is that how can a language like Assamese be added to large language models, and where do the data sets for such low resource languages come from? And what is the general process involved?
Yeah. So yeah, as I said, it's a game of data, right? So if you want Assamese or any of the Indian language to be represented, there's a certain amount of data in that language that needs to be added, right? And what I hear from my friends in the deep tech is that the amount of data as models are scaling up, as they are becoming larger and larger, the amount of data needed for every new language is typically of the smaller order, but still in the Indian context is large. For example, if I say 100 billion tokens, right? So one book is roughly like a Harry Potter sized book is roughly 100K tokens, right? So if we are talking about 100 billion tokens, then we are talking about a million such books, right? To get to 100 billion tokens, we really need like million books in Indian languages, which are then digitized, right? And we need, this is like another of my pet plead, which I keep repeating in different forums, that we should have like a national infrastructure, just as we have a national infrastructure for building highways. We should have a national infrastructure for digitization, right? Where we take all the wisdom locked in libraries across the country and digitize this and make it public good for training large language models, right? Not for violating copyright laws. So these books cannot be sort of downloaded and read from them, but large language models should be allowed to be trained on them. And Japan has done something similar where for training of large language models, copyright laws are exempted to the best of my knowledge, if I've understood that properly, right? So something like that is needed where we have this national infrastructure for digitizing at scale. And then all our languages, if we reach this 100 billion token mark, right? Some of that would come from existing books. Some of that would also come from on the ground. Can we go to every taluka in the country and take interviews from people in their native language about their native culture and so on, right? So what if we go to every taluka in the country and ask what do you do on the day of Diwali from 6 a.m. to 11 p.m. in the night? And this answer would change from taluka to taluka. I've taken Diwali as an example. We could think of any other regional festivals which are there, which may again vary. For example, Bihu may vary from one place to another in Assam itself, right? The way it is celebrated. So if we do this large scale data collection, then we could have a much better representation of our languages. And we should have this national mission of collecting 100 billion tokens in every language that we care about.
Are there any more questions? I think there is no more questions.
Thank you. I will log out now.
Thank you, sir. I now invite Professor Rohit Sinha, Dean Research and Development, IIT Guwahati, who will share institutional and research perspectives on building and integrating language technologies.
presentation में डाल दीजिए रिफ्रेश कर दीजिए इसको शायद वेब से किया है So very good morning, everyone. Myself is Rohit Sinha. Actually, I am a professor in Department of Electronics and Electrical Engineering at IIT Guwahati, and also an associate member of Center of Linguistic Science and Technology. So today, I first of all thank the organizer for giving us the opportunity to share whatever little work that we basically do in the language technology area. And also, we are also contributing to the National Mission on Language Technology, which previous speaker has already discussed in detail about. So we are also part of that particular national effort. We also contribute to that particular initiative of the Government of India. So basically, I stand here to present the work of a lot of my colleagues who are part of the Center of Linguistic Science and Technology. I will tell in detail about what this particular center is all about. So before, as you might have seen, that nation is already making a lot of effort in actually developing language technology. And our country is unique because we have 122 official languages, so not major languages, which has speaker strength more than 10,000. And despite that, we have so much language variety that we have got 1600 languages that are yet to be basically done anything as far as the technology development is concerned. So luckily, Northeast is one such reason, which basically, if you look at the population-wise, we are only 3 to 4% of the national population. But when it comes to languages, we represent a good variety of languages in Northeast. So I begin, my slide will basically tell you where do we stand. Actually, if you look at the Northeast, as far as the language census done in this particular area, there is no exact consensus, but there's something 200 different languages exist in this particular thing. As you can see the map, political map of this particular Northeast India, and you can see each state represent a good number of languages. In Assam, we have got 40 to 50 languages. So these are some original languages, some dialects, and etc. Particularly, so this is the reason why IIT Guwahati, being situated in Northeast, we took the initiative to basically do something for the languages of the Northeast India. And with this particular motivation, we started a Center of Linguistic Technology, whose basic structure I will discuss a little later. So we all know that probably we are living in a linguistically diverse region of the world and certainly of the country itself. And moving forward, if it comes to what is our effort so far, our efforts is tiny as far as the diversity that is exist around. We have basically hardly worked or touched upon some 40 odd languages. So we have got hundreds of languages yet to be basically think. If you basically take a mandate back, IIT Guwahati, we are situated in Northeast, so probably we should try to develop the technologies for the Northeast thing. So of course, the development of this particular technologies, all languages, would be a pipe dream, because a technology development is always related with the commercial sort of gains from it. Somebody will invest into this development of technology. Certainly, they will like to take some return. So the language development will not be happening in all the languages that exist in world or for any particular reason. Of course, the people who are passionate about those languages, the native speaker of those languages, need to basically get educated, or they have to resolve that probably they have to develop technology initially. And later on, those technologies might be captured by the biggies, and then probably a language development in that particular area can take place. So with this particular effort, IIT Guwahati is involved in little bitty languages, and we are doing some technology, which I'll be able to share you over the next slides. So when it comes to the strength of our group, particularly the Center of Linguistic Technology, we basically feel privileged to be located in the region which is so linguistically diverse. Collecting data for us is very easy. Finding the native speaker of those languages is very easy for us, because we have a lot of connection with the institutes of Northeast India, including the neighboring countries, which is Bhutan and Bangladesh also. And we are able to basically get expert native speakers. And of course, we have a student and faculty member who are the native speakers of the various languages, and they are from the various Northeast states. So we are very much, we feel ourselves privileged that probably we have the very mandate to operate or develop technology on these languages. Moving on to what we have done so far, our specialization basically lies, we have contributed to the development of the data collection. As my previous speaker has emphasized, that the technology development requires a lot of data. If you have data, only then the technology can be developed. As some speaker has asked that what will happen, how are these data is coming up? Certainly that data collection need to be sort of done. Right now we have a lot of means of collecting data. Of course, the matter of consent, whether it's ethical or not, that's an entirely different thing. But this is a chicken egg problem. Somewhere we have to develop as a national mandate, and linguistically diverse country like India, they have to take this particular challenge much more aggressively than other countries which are slightly more linguistically homogeneous. So probably we have contributed to the national efforts and our own efforts in this direction, collecting data in some of the languages of the Northeast India. We have annotators who are able to annotate it, and certainly some technologies who are going to develop the modeling of the various kinds of language applications, and certainly we have developed some of the applications also. So these are the some major development, and I'm only representing only those part of developments which are part of the theme of this particular session, which is the language itself. So these are the various things: machine translation, optical character recognition, automatic speech recognition, and text to speech. And I will basically give you a demo of this particular thing in due course. So we have a large set of groups because CLST happens to be a multidisciplinary center. So we have faculty from all streams of the science, linguistics, etc., and they are all contributing to the development of these technologies. So moving forward, we have also contributed to the national efforts, particularly for machine translation, not for the major languages. Basically, our focus is on the Northeast language. As you can basically see, Assamese, Manipuri, Malayalam, and Mizo, we have developed some machine translation systems. Bodo, Khasi, and Nepali, they are under progress. And of course, you can find out the demo of these particular technologies onto the web page, which is already mentioned over here. So I'll give you some demo towards the end for the benefit of time. So moving on to, is basically, all of you must be understanding it in current generation student also, the machine translation, we would require a parallel corpuses. And there's really nature of the corpus is that the text corpus itself. So text corpus, you can easily access it from the various, over the internet, digitized sort of text data should be available in 2 languages, and we call it the parallel corpuses. And then probably we use various kinds of methodology, which are conventional models, some are neural network based model, to basically learn what is the association between the data of the 2 languages. And with help of that, we basically develop these translation systems. So I will basically show you the quality of the translation system, particularly that we have developed in Assamese and Mizo. And of course, others are also there available for you to access from our web portals. So apart from that, the optical character recognition combined with machine translation, this is what, as my previous speaker has also given this thing, they are also looking into it. We have also looked particularly for some Manipur OCR we have developed following the basic Assamese and Bengali OCR based models, and we are able to achieve some good quality translation. Particularly, these are the examples as the this thing. We have been given a structured document in one language. You can see the page of a textbook, and we are able to translate it completely, maintaining the structure of the document, one document in one language to other languages. So these are basically now possible to be done in some of the Northeast languages itself. So this is complete conversion, and you can basically visit our website to see the demonstration of that one. Moving forward, we have also contributed to the national mission of automatic speech recognition, part of all the national projects. And of course, our focus basically on developing the ASR technology for the Northeast languages. We initially started our efforts with the Assamese language, and then probably they are basically migrated to other languages, Mizo, Angami, and so this is what we have basically developed. So I will not play this particular demo because we have a composite demo to show you how these technologies basically work. So our initial project was basically developing as a part of the national mission as some kind of ASR system where the farmers will be able to. So we started from the application point of view first, developing an ASR that ASR, any farmer wants to basically sell his agriculture produce somewhere in different markets. How would they basically come to know of which market they have to know? So of course, a telephone-based interface was being developed where the farmer can dial free of cost to that particular number, and then probably we should make some query about their crop and which market is having what price, and they can basically make, and that interactive voice system was being developed. So we contributed for the development of Assamese, and of course we have also migrated that to the Mizo and etc. So, and of course Angami language also is being developed. So moving forward, so we also have some initiatives taken in terms of text-to-speech system or speech synthesis, what we all know. Particularly, our efforts are focused only on the Northeast language, and we have 2 TTS system, which is for Assamese and Mizo. I'll play some demo of those particular TTS systems. And as you can basically see, these are not the TTS system, which is taking from any foundational model developed for any major language. We have basically train these systems on the data collected for these languages itself. So of course, they are not as as a state of art, or maybe performance-wise, we have yet not evaluated how do we compare with the other system existing over there. But our initiative was to basically create some data, because most of the Northeast language are called as low resource language. They would have no text data, they would not have speech data, there'll be no pronunciation dictionary and etc. So our task was to basically create this database, and using those database we have developed these systems. So these systems are still a moderate kind of system. They are still not very best systems. So look at it, the quality of the reconstruction. Maybe if I able to successfully play these files. This is a Assamese text, so most of you must be able to.
কেৱল বিবাদৰ পিছত কৰ্তৃপক্ষই কোনো আদেশ লিপিবদ্ধ কৰাৰ বাবেই সেই ক্ষেত্ৰত কৰ্তৃপক্ষই ব্যৱহাৰ কৰিব পৰা ক্ষমতা বিত্যাগ কৰাৰ কোনো ভিত্তি হ'ব নোৱাৰে। সাৱৰ সম্পত্তিৰ দান কেৱল দাতাই নিজৰ অধিকাৰ উপাধি আৰু স্বাৰ্থ দানকাৰীলৈ হস্তান্তৰ কৰিবলৈহে দিব লাগে। প্ৰতিবাদকাৰী ভাৰতীয় মেটাল বক্স কোম্পানী লিমিটেডে ননী নিৰ্মাণ কৰি আছিল। বিজ্ঞান একক বিচাৰকৰ যুক্তি তল দিয়া পৰ্যবেক্ষণসমূহ পোৱা যায়।
So as you all know that when it comes to speech synthesis, the current technology is basically takes up some pivot speaker and probably male or female and etc. And they have to basically develop the system for that thing. Still, you will like to synthesize in all different kinds of speaker. That much research is still under progress. You will have most of the TTS system taking up one golden voice or one pivot voice, and they will try to work on that particular speaker's voice itself. Of course, you can create your system for multiple speaker, but still, if you want to synthesize anybody's voice, you will have to first collect a lot amount of data for that speaker. Only then you will be able to synthesize. So this is our effort. So this is our effort for the Mizo language, which is very low resource language.
Kemalang na hi may chenao pangtetan pei chuan achangkai hle don ani ati. Hei hi shidar zel tur ti top na tur ani thu an soi. Hei po hi chin felran thei thuai anin be sei ti an soi.
So I'm not a native speaker of Mizo, so I do not know what is the quality of this reconstruction. But those native speakers who have gone through it, they have liked the quality of the reconstruction. I will just like to share one piece of information. When it comes to languages, there are some languages which I'll call as non-tonal language, others are low tonal language. There are few languages which are tonal, in which the tone in which we pronounce a particular word changes its meaning. So Mizo is one such language where it's a tonal language. So we have tried this particular synthesis using some latest neural network model, in which we do not explicitly model the tonality of the language. Still, the system with what amount of data that we have trained with is able to get the tone modeled implicitly, and the accuracy of the train is a bit surprising. It's quite good. Native speakers have evaluated. In our assessment, we have found our quality is about 80 to 90% tone accuracy is correct without explicitly modeling it. So this, we have basically published this particular work to submit it to a journal, probably it's under review. But this is partly related to the fact that speciality of the Mizo language, in which the tone is somewhat dominant and is not very confusing. So apart from other languages which the tone is being modeled, like Bengali or Mandarin and etc., there they basically model the tone in a very explicit way. And of course, the complexity of the tone could be the answer, but in Mizo, we are able to develop on a very small amount of data, something about not more than 5-6 hours itself. We are able to get a very good reconstruction with 5-6 hours of the data reconstruction of the tonality of the language itself. And some of you, if you are from the native speaker of Mizo, might see whether it makes much sense or not. Moving forward. So I just play a composite demo for the benefit of time, which basically demonstrates some of these technologies that we have developed. As far as the application of our machine translation effort is concerned, we are just not trying to develop a very big foundational model, which is being developed under the Bashni initiative. We have basically addressed one of the challenges which one of the speakers have tried to highlight, does this particular system work for any particular application or not? So we were fortunate to have been given one project from the Guwahati High Court that they often give out a lot of verdicts and they need to be basically translated to various languages and etc., particularly for Northeast. So we have made some effort toward that particular thing. Our machine translation system has been basically successfully deployed in the Guwahati High Court to translate the verdicts given by the High Court into different languages. So this demo did mention about that particular initiative also. So I just play a composite demo which gives us a lot many technologies which the CLST group has worked on. This is a peep preview. It's not a very detailed description of all the technologies that.
মাদ্ৰাজ উচ্চ ন্যায়ালয়ে এই মতামত গ্ৰহণ কৰিছিল যে কোম্পানীটো প্ৰবন্ধটো হস্তান্তৰ কৰাটো কেৱল ধনৰ বিবেচনাৰ বাবে নহয়, এই বিক্ৰীৰ সমান নহয়।
কৃষিজাত সামগ্ৰীৰ মূল্য সন্ধানলৈ আপুনি বিচৰা জিলাখনৰ নাম কওক।
তিনিচুকীয়া।
আপুনি ক'লে তিনিচুকীয়া। আপুনি মূল্য জানিব বিচৰা সামগ্ৰীবিধৰ নাম কওক, যেনে আলু, বেঙেনা ইত্যাদি।
মিঠাতেল।
মিঠাতেল। আজি ৰাতিপুৱা মূল্য হ'ল 201 টকা 15 পইচা। আপুনি যদি অন্য কোনো সামগ্ৰীৰ দাম জানিব খুজিছে, হয় বুলি কওক, অথবা ফোনটো বন্ধ কৰিবলৈ নহয় বুলি কওক।
নহয়।
কৃষিজাত সামগ্ৰীৰ মূল্য সন্ধান ব্যৱহাৰ কৰাৰ বাবে আপোনাক ধন্যবাদ।
Have you ever wondered how traditional textbooks can hinder the learning experience of children with ADHD? Meet Varun, a bright and curious student who faces this very challenge. As Varun opens his textbooks to learn, he finds himself lost in a sea of distractions. The small font, cluttered illustrations, and large amount of text overwhelm his already limited attention span. But why does this happen? Varun has recently been diagnosed with ADHD. ADHD stands for Attention Deficit Hyperactivity Disorder. Through meticulous experiments and a longitudinal study, we discovered design parameters that could transform Varun's learning journey. The perfect blend of font size, type, line spacing, and background color became the key to unlocking his focus. These parameters were then compiled into a set of our visual design guidelines to redesign textbooks.
So now I will have the privilege to basically share with you what kind of national language technology mission project we are involved in. So we are involved in currently 2 projects, which is basically one is the Indian language data collection. So we are basically collecting data in Bodo, Nepalese, Assamese, Manipuri for translation purposes. We are creating the parallel corpus for this machine translation in these languages. Apart from that, we are also developing a healthcare domain keyword detection system, particularly focusing on the Northeast language, Assamese, Manipuri, Mizo, Nepali, Bangla, of course, involving Indian English and Hindi itself. So this will be basically the 2 effort that we are currently involving as far as the national technology language mission is concerned. Coming on to last but not the least, what is the CLST? CLST stands for the Center for Linguistic Science and Technology. It was started in the year 2024 with a mandate or with a mission to basically preserve the lot many language variety which exists in the neighborhood of our institute itself. So we thought that probably like-minded people have collected and made an effort to start up a multidisciplinary center to basically take some initiative through research and technology, train the students of those native languages, because they will be the real stakeholders on developing the technology development in the various kinds of languages that we have. This particular center is basically have an interdisciplinary nature. It has basically faculty member from all these departments, mainstream department that you basically see. And we are proud to have a very diverse team, which involves not only the computer science, electronics, design, linguistics, mechanical engineering, humanities, and etc. So we have a vast coverage of faculty members, and you can visit our website. We do offer two programs. One is an old program, that's a PhD in the linguistic science and technologies, which has been started when the center was started in 2015 onwards. And we have recently started a dual master PhD program. So I can see a lot of young students and budding researchers. You're most welcome to apply to the Center of Linguistic Science Technologies, and you can carry over your passion of developing any kind of technology. So we do offer a lot of internship to the students. So you can always welcome to write to us to have your interest in any particular language technology of your reason, or any analysis of the peculiarness of your language and etc. We are always ready to have those initiatives fruitfully answered. So with this, probably I come to the end of my presentation. Thank you very much for your attention. And as all of you might know that there are stalls outside. Center of Linguistic Science Technology has also put up a stall, so where you will be able to see our students, our more details about the project, which I have given you pre-preview. So you are most welcome to visit that particular stall. And thank you very much. If you have any question about our, I think I'm more than happy to answer it. Yeah.
Hello, sir.
Yes.
Myself, Tanmay for Guwahati University. Sir, here.
Yes. Yeah.
Sir, I have a little bit controversial question. So, heavily investing on this type of AI, why shouldn't we focus on improving the English proficiency of the Northeastern people? It will help us for a global opportunities also. So, how will you defend this question?
So I could not understand your question once again.
Sir, heavily investing on this type of AI, language-specific AI,
Yeah.
why India should invest on English proficiency of the people of Northeast?
Yeah, so look, English proficiency is basically because a country is just not always defined by our neighborhood itself. So a country would be strong when we are able to basically take our influences outside our boundary itself. So there'll be, for that, probably the English is still considered to be very well-connected language. So proficiency in that one is always required. But as far as the language is concerned, this is our old culture. This is our heart, inner soul. So for that, we have to basically, just like a passion, we have to pursue it. If our language happens to be a very dominant language, certainly all those efforts would have a commercial meaning also. Otherwise, I think these are the two things which are simultaneously required. You have to preserve and develop technology in your native languages, which you have unique languages that we have evolved over millions of years. All these developments is a human history also. So just like we have museum of the artifacts, why not we have a museum of some languages also? Because very soon with this globalization and etc., all these languages are fast being forgotten. If there are very few speakers are of the languages, and we have challenges like, as previous speaker did mention, that we would like to speak in the colloquial language, which will have code mixing of all many different words, borrowed words, English included. So of course, preservation of language is an entirely different passion, which is also need to be also addressed to, apart from acquiring a skill which I have global outreach. Certainly that is also welcome.
Thank you, sir.
If you have questions, please raise your hand. I will come to you. Good morning, sir. I'm Polas Boro from Pragjyotish College. I like your initiatives for the native language to be translated in the AI. For the Boro language, how the accuracy will be like completely 100%?
As mentioned that we can always take up the whatever is the major languages that we have got, we can always take up foundation model for those languages, and certainly we can fine tune the models for the any particular language. Certainly when it comes to language, we'll have to look at the what is the acoustic closeness of a particular language. Languages are of various varieties, various sort of streams, and of course a language, major language in a particular stream which is closest to it, certainly we can take the help of the existing resources in that language to fast forward the technology development of any low resource language. But whatever may be the initiative, you have to fine tune the model for any target language. Say you are interested in Bodo. So for that, you have to have some data. No model without any language will be able to work good for any given languages. So despite whatever you will be able to, you have to fine tune it. For that, you have to have a data. Whether you will be able to collect the data to compete with a always model trained on that language itself, that will depend upon how much you're going to invest into it, what will be the commercial output. But collecting some data is always required. And once you have collected enough data, you will be able to fine tune a model which will not require the years of effort which has gone into some major languages. So that will reduce the commercial cost of development in a model in any languages. But certainly there are very much vast diversity languages exist. These statements not be qualified for all languages. So looking at the particular language, we'll have to see somewhere we have to still collect more and more data to be 100% as you. 100% is never possible for a technology is always where it is below our expectation level. So as somebody was trying to say that there should be no correction. If you think of, even if you have a trained stenographer, it's trained to you giving dictation and producing letters for you. Still, they will make mistake. Of course, the human mistakes will be far and less. So of course, these language model will also be keep training, and over the years, if you be slightly patient, we have seen how the display that you see was not the display when the television service started. Now you look at the display right now. So we have to be patient with any technology. As far as the language technology is concerned, the effort is on from long years, but the emphasis is very recent. It's almost like 2 decades, etc. A lot of language technology development has been taken across the world. And of course, within another 2-3 decades, I hope we would not consider this to be a problem with any other languages. So this is my hope that probably this problem will not exist for many languages. Still, this statement is qualified, not for all languages. So statement can never, a scientist can never say that it will always happen for, but there are various kinds of languages which do not have any correlation with any other language. So for that languages, you have to be, again, start from the scratch.
Thank you, sir.
So next question.
Good morning, sir. My name is Fariha Firdosh Ahmed. I'm a student of West Guwahati Commerce Senior Secondary School. So my question to you is, although AI is often seen as a tool that helps students understand difficult concepts by translating or simplifying language, does its use of complex vocabulary and formal structures sometimes makes learning harder for students?
You're very right. As look, when it comes to having any AI tool which will help you, so basically you will have to adapt it. Just like suppose if you go to any restaurant of any repute, are you expected? Everybody is expected to get the same taste? No. Everybody has different palate, so they will have taste. So according to you, everyone, as somebody was mentioning yesterday, that someday we will have AI as our tool, which we like to personalize, just like we personalize the phones. Previously, we used to use public phones. Now we all carry our own phone. Similarly, we will also carry our AI, and that AI will be personalized to us. And of course, it will take care of your taste and your expectation from it. And it will keep correcting over training. So if it makes error, there are mechanisms through which we can incorporate that error, that it will try to overcome that error next time. So of course it'll get personalized to the subject. So if you have a difficulty in some vocabulary words and etc., if it finds it, so there'll be training, it will learn itself, and it'll try to offer you a simpler vocabulary rather than a very complicated one. So it's very much feasible.
Thank you, sir.
Excuse me, sir. One more question.
Yes.
Good morning, sir. Yeah. Myself Ziggas Chakravarti from West Guwahati Commerce College. My question is, it's very good thing that AI can translate in any language, but there are some plot holes and loopholes where it can lead to mistranslation and which can lead to social harm. And how will you prevent this? Where are the safeguards of it?
No, every technology comes with the pros and cons, and the way the human society has developed, and those societies who have developed more, they have adapted the technologies. They are flowed with the current itself. So no technology you can develop which will not have any harm. And as a society, we have to create restrictions, some regulations, and etc. And apart from that, ethics. If we don't have ethics, everything is dangerous. So of course, if we have high ethics in the society, then probably this ill effects of any technology can be minimized, can never be eliminated. So if we have a technology, any technology comes with a lot of weaknesses. It's an innovation. It incites us. We all get used to mobile phone, but of course, we now carry a lot of data in our hand, which can be stolen and gets stolen. We have digital arrest. So it doesn't mean that probably we will always evolve. Human beings are ingenuitive. Whatever technology they do, the people will be there to break and misuse it. Of course, we have to develop the regulation and of course, develop a high ethics that is very much required for even without technology or with technology, life on this planet. So if we have high ethics and if we do not appreciate the ill use of any technologies, of course, that usage will get diminished.
Yes, I agree with you, ethics. But are there any official safeguards like coding language safeguards that can developer make to prevent a mistranslation or something like that?
So there is a lot of standardization has to take place in the language technology domain. So right now we are into a demonstration domain in which we show this is all feasible. Once a technology is established, like previously, there's so many different mobile standards were there. So later on, some standards happen, some has lost into oblivion, some has survived. So similarly, some regulation, all governments across the world or globally or locally will develop the due regulation, which will basically be developed. So right now, we are not having too much of a standardization as a language technology in best of my understanding. So
thank you, sir.
Regulators' roles, yeah.
Yeah.
Next question will be from other side.
Thank you. The session was very, comprehensive, and it was really commendable. I have, sir, 2 mentions and 1 question.
Yeah, sure.
The development focus on language was very crucial, and we are focusing on our regional languages. Sanskrit is one of the language we can use it in these like we are using English. And second thing is that we can implement as this focused in human capital. So we can utilize our technology by more involving in regional affairs like melas. We recently have Mahakumbh melas. Yes. So we can leverage these things, and it will often optimize various aspects. So my question is that how do you see, the regional touch as well as contribution to this human capital of our?
I think if you just look at as far as the human spirit is concerned, and I feel surprised how in olden time people traveled across the globe in our sense. Right now, we have so much means. People have come on foot, traveled from China to India. How they might have encountered, collected the knowledge which they have come to collect. So many different reputed visitors from various parts of the world have come. They have come, they have a lot of patience, they have learned the language of that land where they have come to basically garner experience from. So compared to that one, we are much better off. Of course, we do a lot of travel. As you mentioned about our country itself is a big globe itself. We have so much diversity. People do come for a festive that you have just coined out as Kumbh Mela across India. So of course, all these language technologies can be certainly be deployed to basically help sort of ease any kind of pilgrims or whatever the travelers that are going to come up. All these technologies very soon will find, and as you can say, Bhashini, there's a much more greater effort has been taken up, which will be given to startups, and they will certainly develop lot of applications. So when you talk of this technology, there is some technology demonstration is often done in the academic institution. When it comes to application development, this is where the startups or the companies have to take initiative. So that's why the government of India is also encouraging to create a startup. So all these areas, so newer students who are the budding researchers, they have to think of what kind of application I can develop, garnering a technologies which is available in XYZ sources. These conferences or these kind of venues provide you to look where the technology is available. How do you basically grab any particular technologies, come up with an application? There are a lot of, all these institutions have startup incubation culture. So you can come with a application, and certainly they will incubate your application, provide you whatever the academic skills and etc. models that they have got, they can share with you, and then you can start up a company and start serving your niche population or the nation at abroad. So this is where the things will be there. Application development is again an open game with the research institutions like IIT and etc. may not be directly involved. They may certainly be encouraging the startups to take up this particular challenge and take it to the masses. So, any other question? Please feel free. Yeah. Thank you very much for your time. Thank you once again. Thank you.
Thank you, sir. I now request Dr. Tina Sharma from IIT Guwahati to felicitate the speaker. Ladies and gentlemen, we now move to a special session titled Collaborate with Bhashini, Build an Inclusive and Empowered India. This session will highlight India's efforts to build an inclusive digital ecosystem by enabling access to technology across languages, particularly focusing on outreach and engagement in the northeastern region. It is my pleasure to invite Ms. Jyotishmita Devi, Engagement Manager, Northeast India, Digital India Bhashini Division, Ministry of Electronics and Information Technology, Government of India. I invite Ms. Jyotismita Devi to kindly take the stage and begin the session.
Thank you, everyone. All my previous speakers has spoken about all the technologies available in the language field. So I am planning to give you some demonstration from start.
मैं एक साधारण परिवार से हूँ। मैं गुवाहाटी केवल एक साइकिल और एक कीबोर्ड के साथ आया था और कुछ नहीं। तुम्हारे पिताजी मुझे साइकिल पर कीबोर्ड लेकर घूमते हुए देखा करते थे। तब से लेकर अब तक जो भी मैंने पाया है, मैं उससे खुश हूँ। मेरा मानना है कि इंसान का खुश रहना बहुत जरूरी है, चाहे कितना भी तनाव या चुनौतियां क्यों न हो। हर किसी को अपने भीतर खुशी पैदा करना आना चाहिए। जिंदगी में सबसे अहम चीज है खुश रहना, तभी अच्छे परिणाम मिलते हैं। यदि कोई स्वयं को खुश रख सकता है तो वो दूसरों को भी खुश रख सकता है, लेकिन अगर वो कोई यूं ही उदासी में बैठा रहे तो वो दूसरों को कैसे खुश रखेगा।
So this is a tribute to Zubin Garg from Bhasini. So the original video was in Assamese, but we used a tool called Chittanubad through which we had translated it to Hindi. Also, I'll show you another video. This is a application where you can use all these language technologies.
డెబ్బై రెండు యూనిట్లు వచ్చేయండి.
ఓకే, ఇంకా సబ్సిడీ, దే వాంట్ సబ్సిడీ and you can read it. ఇంకా ఏం కావాలి మీకు?
Bringing me thus far and for giving me this opportunity to share about my journey and my self journey. That's all. Thank you. Kublai Chipor.
కింద 30 సభ్యులకు గాను 40 లక్షలు మంజూరు కావడం జరిగింది. మా సిఎల్ఎఫ్ ద్వారా సిహెచ్సి సెంటర్స్ వ్యవసాయ పరికరాలను అద్దెకి ఇవ్వడం జరుగుతుంది మరియు మానవాభివృద్ధి కార్యక్రమాలను చేపట్టడం జరిగింది. మద్యపాన నిషేధం.
So this was an event where all the rural women came and they spoke Indian native languages. And you can see a demonstration of this app here in the screen. It is called Shrutlek. What I am speaking in English is being available to you in Assamese and in Bodo. So now coming to my presentation. So I am a representative of Hasini. Hasini stands for Bhasa Interface for India, and it has been established under Ministry of Electronics and Information Technology. And we are a part of National Language Translation Mission, as all my previous speakers have spoke about all the language technologies being developed, and we are faced. The backend are all higher education institutes and researchers who has actually developed the technologies. So our mission and vision is to make every citizen digitally empowered in their own languages, so that they can speak in their own language and feel at home in any place. For example, আমাৰ নৰ্থ ইষ্টৰ মানুহবিলাকে বহুত চেন্নাই যায় বা বাহিৰত যায় বেলেগ বেলেগ ধৰণৰ এয়া কৰিবৰ কাৰণে মেডিকেল ৰিলেটেড বা পঢ়া শুনা কৰিবৰ কাৰণে। কিন্তু আমি যেতিয়া তাতে গৈ পেলাই যদি আমি অসমীয়াত কথা ক'ব পাৰোঁ আৰু সন্মুখৰ মানুহজনে ইংৰাজী বা তেওঁলোকৰ নেটিভ লেংগুৱেজত শুনিব পাৰি আছে, চ' ডেট ইজ দ্য পাৱাৰ উই আৰ লুকিং টু ডেভেলপ। So our goals is to make our voices first, so that we can interact through our voices, and in any place, so that someone, your grandmother, your mom, or like very old people, someone who might not know how to run a website or internet, but they can, obviously they can speak, and they can interact with the digital systems with the computers with their voices. So this is our goal. So this there was one question like, why are we looking to develop, why are we not looking to being fluent in English, rather we are developing our language models. So I would like to add here, so that we are we need to preserve our languages, because as sir rightly said, we need to have our identity first. So that is our one goal. There is like many languages are being extinct. There are very few people are there for those languages. So we are looking to work on those languages as well, so that those languages can be preserved and carried forward to the future generation. So so as I have said, we want to enhance our mother tongue, through which we can interact with everyone, with the digital systems. Even we want to go outside of India and like to talk in Assamese. So this is also give a faster delivery of government services, because when you are going to apply for a form, let's say death certificate or some birth certificate or something, someone need to know the English. So if we have these applications, language technologies with us, we can interact with the voice, with the systems, then we can just speak your name, your village name, then the systems will capture, and the application will be done. So there are different agriculture related, education, public sector, and everything is being done in this language, in this our native languages. So there are multiple tools available here, which is like one is Anubad, which is a web service. You can have text to text, voice to text, text to speech, and there is also Chitranubad, which I demonstrated the tribute to Jubin Garg. It was done by Chitranubad. There is a Lekhanubad, which is like PDF translation. Then there is a translation plugin, where any website you are interacting with, like you are interacting with Facebook, Instagram in English, but if through this translation plugin, those websites can be interacted in Hindi, in Assamese or Hindi. And there is also Vasini mobile app. In the mobile app, if you download, you will find a converse button. You may speak in one language, and the listener can be listening in another language. And there are other tools as well. So as I said, we are looking mostly voice to voice, like we are giving more emphasis on voice journeys. So we have many real-time speech to speech. This Shrutlek, which I had just demonstrated, This is like voice to text transcription, then it is translated to other language. So there are like audio transcriptions, real-time speech-to-speech chatbots. Now coming to the our northeastern states engagements. So we are connected with all the state governments of northeastern states. We have already signed MOUs with Tripura, Meghalaya, Mizoram, and Assam, and there are many language models available for northeastern states with us. And mind you, we did not make the language models. It was made the models were made by higher education institutes like IITs, IIITs, and all. So we have launched some language model improvement hackathons or innovation challenges. So these are in Mizo, Khasi, and Garo. So in Bhasini, we also have some open APIs, models, and datasets which this any students or researchers can can access and do their own research based upon that. Then we also have Hasadan workshop through which we connect with different organizations, means different institutions and individuals. And also there is a Anusandhan Mitra program for all higher education institutes. So I'll talk a bit about on this. So first I would like to talk about this hackathon, because there are lots of students over here, we want all our students to participate in those hackathons, and Bhasini keep launching different kind of hackathons. Of course, all are in language technology itself. So in Northeast, we have hackathons in three languages, Mizo, Khasi, and Garo. And all these models are like low resource languages, and we want to make this resource language models improved and developed. That's why we are conducting the hackathon to collect more and more data and also develop models. And we also support through prize money, and there are also mentorship available, and even there after the model is developed, they will be kept in our website. It is really open sourced. So talking about the Bhasini API, Bhasini API keys are available for students, researchers, and startups, and there are models and data sets, all are open sourced, and you can access this models in bhasini.gov.in/bhatika. There is the website link. So there is we have launched a Bhasini Gyan course, and this is a centralized knowledge hub, because in here all this data annotation, data cleaning, and everything there has to be some standard quality, and we have ensured that the quality and consistency is seamless. So all these quality standards are mentioned in the Gyan course. So it is helpful for all the developers, researchers, policymakers, innovators to get those standards in one place. So Bhasini has some data contribution initiatives, which are one is data done, where we collect data, different kind of data in domains like agriculture, legal. So this kind of data we collect, and it is, as you all have already know, that the models perform as you teach them. So the domain data helps us to make the model work in those domains. And there is, of course, Bhasadan, where Bhasadan is a platform which is open to all. So we have it is available in our website. So it is a crowdsourcing initiative where you can bolo, dekho, suno, and likho. So there will be some things, some speeches, some text coming up, which we need to contribute in terms of bolo, dekho, suno, and likho. And Anusandhan Mitra, it is an exclusive platform for higher education institutes and research organizations. I would also like to IIT Guwahati to be a part of Anusandhan Mitra, because So in Anusandhan Mitra, it is a in Bhasini itself, there is an onboarding portal where you need to submit your proposals, and of course, there are some due diligence is done, and the research organizations are onboarded. So I have told about this onboarding portal. So onboarding portal is there in the bhasini.gov.in website. You can just log in as a maybe developer, government organizations, researchers, private institutions. So there you can log in and apply for the different services, different tools which you may able to use. So I have kept my presentation short, and that is all. Oh, I would like to show some use cases. So we have a use case with Ministry of Panchayati Raj, where an app was developed which is called Sabhasar. So in the Sabhasar app, there are Gram Panchayat meeting happens at the village level. So through the Sabhasar app, all those meetings can be captured. Those will be like voice to text, and those texts can be directly uploaded to the central portal, so that the person sitting at the highest level at the ministry can access the proceedings of these meetings. And in the Pehchan app, it has become a multilingual birth and death registration has been enabled. And in the Sangsad, we have, there's a Sangsad Spradha innovation challenge we had launched, and there we used all the legacy documents preserved through ASR, and presently all the documents are being translated. So that is all from my side. If I have any question, if you have any questions, I'll be happy to take.
A very good afternoon. My name is MD Raju Ali from e-office team.
Okay.
Okay, so my question is, how much perfection does Bhashini gives in the direction of phonetics whenever we do the speech to text conversation?
Yeah,
Translation, I mean.
How much what?
How much perfection does it give us in the direction of phonetics?
Phonetics.
Because when you show the live demo, when you said SMEs, it written there SME/S. So I believe that it's not perfect yet.
Yes.
So how much perfection does it give to us?
So it is very difficult to give you a percentage wise, like how much it is giving perfection, because it is all about feeding the data. I guess the SME's word is not being fed properly. That's why it is coming it like that.
I believe the problem is regarding phonetics side, the way we pronounce, so it is not able to catch that.
Yes, yes.
So all I'm asking is, I'm not asking the percentage, like it is okay, good, average, better, best, in that sense.
I think except a few words, it is coming okay.
Okay, that's all. And my colleague have some question regarding e-office.
Yeah.
Vasani.
Hello. So I'm Nilfar Yashmir from e-office team. So my question is, since we have integrated Vasini in e-office, how do the user feedback, like how can we intake the user feedback and enhance the Vasini language terminology with respect to Government of Assam terminology? Like a very simple example, when we use the Vasini, in generally, whenever a file number is written, it is NO dot. That is the general terminology that the user uses. So when we translated in Vasini, it came out to be Nai. Ohomiyat Nai hoy gol. So how do we enhance the database so that whenever we are using the Vasini through the e-office application, the application automatically identifies this kind of terminology and corrects it with respect to government policies, acts, terminologies. So how can we incorporate the user feedback to improve the Vasini translation service?
I I think there will be some feedback button in that e-office portal itself. Is it not
Okay.
there? There should be something actually.
Okay, but in the Vasini, we do not have a direct feedback. So if we can have a
So if you can you switch to my screen, please? Yeah. So in Bhasini, I'll just show. In So in case of translation plugin, if you say there is a feedback button here.
Okay.
So here you can just share your feedbacks here, and for Anuvad also. So here also, if you there is a star button. Sorry. So if you rate this translation as bad, then you can give the feedback.
Okay, thank you.
Anything else?
Good morning, ma'am. I am myself Ankur Sharma. I am from Gijananda Chaudhary University. My question regarding Jubin Garg's art: is it right and legal to use AI to create art inspired by Jubin Garg, or does it change or weaken the originality of his art?
So yeah, the original art is always there. I can show you the full video, but it is just a tribute from our side. It is not for. It is not anything. I don't know. We gave due credit to the interview who took the interview, and we just translated and showed like this can be done.
Thank you, ma'am.
Due to lack of time, we will move on to next session. We will close the question answer session.
Sure. Thank you.
Thank you, ma'am. I now request Professor Ranbir Singh from IIT Guwahati to kindly felicitate the speaker. We now proceed to the technical session 2, titled The Reverse Engineering Approach to AI Education, organized by the NEST cluster. The Northeastern Science and Technology Cluster is an initiative of the Ministry of Development of Northeastern Region donor through NEC, which will be implemented by IIT Guwahati. The cluster aims to promote research, innovation, and skill development in the thematic areas of semiconductor and artificial intelligence, grassroots technologies, bamboo-based technology, and biodegradable plastics. The cluster aims to connect academia, industry, research, and government agencies to empower the Northeastern region youth and women through skill development and entrepreneurship. The cluster was launched in the month of November 2025 in the august presence of Honorable Union Minister Sri Jyotiraditya Scindia ji. Now we will have a short documentary of the NEST cluster.
Welcome to the dawn of innovation and collaboration in Northeast India. Presenting the Northeastern Science and Technology NEST Cluster, a Section 8 company, an initiative conceived as a transformative platform to promote research, innovation, and skill development by the Ministry of Development of Northeastern Region through Northeastern Council at IIT Guwahati. Anchored in the philosophy of inclusive and technology-driven growth, the cluster seeks to serve as a vital link between academia, research institutions, and industry with the ultimate goal of fostering regional development. With 4 dynamic verticals, nurturing grassroots innovations, not limiting to advancing artificial intelligence and semiconductor technologies, championing bamboo-based solutions and promoting biodegradable plastics, and plastic waste management, and much more. The cluster is a beacon of hope where innovation meets opportunity. The cluster aims to work through a self-sustainable model with the philosophy of skill development of youth of Northeastern region in relevant fields of science and technology. We empower aspiring entrepreneurs with specialized training, certification programs, patenting, technology licensing, and customized development in our tinkering labs, all aimed at fostering startups and accelerating innovation in the region. Join us as we unlock the true potential of Northeast India through technology, entrepreneurship, and collaboration. IIT Guwahati feels honored that the Honorable Union Minister of Development of Northeastern Region, Shri Jyotiraditya M. Scindia ji, is with us for the grand inauguration of the Northeastern Science and Technology Cluster.
This session will explore innovative approaches to preparing future AI workforces by encouraging problem-solving, curiosity, and hands-on engagement with real-world challenges from early stages of education. It is my privilege to invite Professor Amit Avekar, Professor, Department of Computer Science and Engineering, IIT Guwahati, to deliver the session. I invite Professor Avekar to kindly take the stage and begin the session.
Fine. Hello, good morning, everyone. Welcome to this session on reverse engineering approach to AI education. I know that I'm standing between you and your lunch, so I will be quick, I'll be brief, and I'll keep this session as much interactive as possible. So just a show of hands, can I know how many of you are school students here? Are there any school students? A few in the back. few in the corner, in the front, and oh, there are also many at the top. Okay, and how many of you are college students here? Okay, quite many of you. Okay, fine. So what I have done is that I have geared this talk mainly for school and college students. So we'll start really from basics and then move further. Okay. In between, if you have any questions, any doubts, feel free to ask the questions. Do we have any volunteers here around with the mic? Yeah. So there are volunteers around with the mic. If you have anything to ask in between, feel free to interrupt me. Okay. So let's start. Okay, so just to give a brief introduction about me, I work here at IIT Guwahati. It's been about 15 years and it's a happy ride. And we do many interesting things in AI. Okay, so let's start to understand the title. Okay, the title is about reverse engineering approach to AI education, right? So let's first understand what do we actually mean by engineering, okay? So if you look at the etymology of word engineering, it comes from the Latin word engineer, which means to devise, to make something, okay? So typically, what do you expect an engineer to do is to build systems, to build something that works to solve a problem, okay? And if you look around, there are many problems, okay? So here is an example of one problem, a couple of problems that I have shown. On your left, you will see a problem that many of the remote villages, they do not have good connectivity. And the school students, they perhaps have to swim the river or a stream to go to the school, okay? And there are many such social problems around, okay? We as an engineers, we have to devise the solutions for these problems. So somebody might go and build a bridge. Somebody might come up with some other innovative solution. So what engineers are supposed to do is they are supposed to look around for the problems and solve them, okay? On the right-hand side, this is the problem perhaps none of us have faced in the recent years about the food shortages, okay? So a few decades ago, India had a lot of food shortage. But again, we did tremendous work in improving our food yield through the science and engineering, and we could solve the problem, okay? So engineering is about solving the problem. Some of you are school students and who might take up the career. So I'll highly encourage you to think about engineering as the potential career. Second thing is, if engineering is about a process of moving from problem to a solution, reverse engineering is exactly the opposite process, okay? Where you have a working system and you are trying to understand why it works, how it works, and you're trying to understand the logic behind it, okay? And there are two interesting examples here. On your left, there is a photo from a temple called Somnathpura Temple in Karnataka, which I just visited a couple of days ago. The temple is constructed in 13th century, okay? And if you look at the pillars of the temple, it consists of exact concentric circles, okay? So back in 13th century, we did not have any machinery that could actually create the pillars of this exact circular shape, okay? So we see this as a system which was built, okay? We see the temple is around, but we have no clue how this might have been made, okay? So any guess how this might have been made? So these are not approximate circles. These are exact circles, okay? You can go and do the measurements, okay? And these are the circles of various sizes. Any guesses how things would have been made? Because this is what we have to do for any other system that we see. It's a system that is there, and we question how it might have been made. Okay. Are you aware of something called a soapstone? So soapstone is a special kind of stone which is found in the southern Karnataka. When you extract it out, it is as soft as soap. Okay. So you can literally carve it the way you want it. But as it gets exposed to the air and temperature, slowly it hardens. And over a few months, it becomes as hard as any other rock. Okay? So when they excavated this soap rock soap, they could easily make it into concentric circles using the pottery kind of techniques. And once it was prepared, then it was installed back. Okay? So that's the reverse engineering. You see the system and then you understand how it was made. Okay? Second, on your right is an example of another system that every one of us uses all the time, the human brain, but we know very little about how exactly the brain functions. Okay? In the past century or so, we have made quite some advances in understanding how the brain works, but a lot of secrets are still hidden. Okay? So when we talk about reverse engineering anything, what we are trying to do is understand how exactly the system was made. Okay? third word in the title is about intelligence, okay? So this whole summit is about AI, which is artificial intelligence. Within that, what exactly is the intelligence, okay? So intelligence is not about doing a specific job, a specific work, okay? The idea of intelligence is to be able to do anything, okay? You should be able to acquire any new skills. If you go and look in the history of computing, in 70s and 80s, we had many systems called expert systems that could do one specific job well. So you had expert systems that would work as a dentist, expert system that might work as a tax consultant. They would do one specific thing in a very narrowly defined, brittle way, in a hard-coded way, okay? Compared to that, the systems that we are building today, they are quite different, okay? They are not limited to one particular task. They are not rigid. They are not predefined, but they can do many different things. And here are 3 examples that actually tell us how intelligence has evolved in the past 3 decades, okay? So on your left top, you might see a photo. People who are of my age, perhaps they will recognize what that photo is about. That's Garry Kasparov, who was the world champion. And in mid-90s, there was a famous match between Garry Kasparov and the Deep Blue system from IBM, 1997, okay? And in 1997, the Deep Blue system from IBM could defeat Garry Kasparov, okay? And that was a big news, that finally computers are able to defeat human expert in the game of chess, okay? But the thing with the IBM Deep Blue was that it was a system that was based on simply doing a brute force kind of search, okay? So it could play chess, but it could do only that thing and nothing else, okay? It was doing simply a very fast computation as compared to the human, and it could defeat the chess master, okay? Fast forward to 2015. Do you recognize the second image on the right-hand side? It was another match between a human expert and a computing system. Okay, this time instead of chess, it was the game of Go. Okay, and the person that you see in the picture is Lee Sedol, who was the world champion in the game of Go, and he had to play against a system called AlphaGo, which was developed by DeepMind. Okay, AlphaGo was far more superior to the IBM's Deep Blue, but still it could play only one particular game, which was the game of Go. But instead of doing the brute force search and brute force calculation, it was actually a system that was trained to learn from the millions of Go games that were played before. Okay, so now we moved from hard-coded search to a system that could learn from millions of games before in the matter of 2 decades. Okay, so from 95 to approximately 2015. Okay, and the third image that you see, which is below, which is AlphaZero AI. It's another system, again from DeepMind, but it's even a step further, okay? So it can play not just the game of Go, but many other games, such as chess and other difficult games. And it doesn't need a large number of games to train it, okay? So for example, AlphaGo, it required millions of games that are played before to understand the strategies for playing the game of Go effectively. That's not the case with the AlphaZero, okay? All it needs is the description of the rules of the game. It will start with absolutely no experience, absolutely no training, and it will go on playing millions and millions of games with itself. From that, it will understand what are the good strategies, what are the bad strategies, and eventually, within a matter of days, it would go and beat any human expert. So from 1997 to 2026, look at the evolution of the intelligence from a hard-coded system that can do brute force search to a system that just needs a description of what needs to be done. It can do any game, anything on its own. Okay? So that's what the intelligence is about. It's about acquiring new skills, doing anything new. Okay? The next thing is artificial, because AI, of course, all of us are intelligent. That's what we would like to believe, but we are naturally intelligent because we are a product of nature. But when we talk about anything artificial, we are typically talking about anything that is man-made, that does not exist in nature readily. And again, here are 2 examples that you can see. One is the artificial limb. So many people, they lose their limbs due to accident or some medical condition. and typically we replace them with the artificial limb. Okay? When we say that any artificial system is a replacement, is an alternative for a natural system, what is it that we expect that artificial system to do? Should it mimic the input-output relation, or should it mimic the way of functioning? Okay, that depends on what is it that we want. Okay, on your right, there is a second example, which was recently developed by a company in Serbia. This particular algae, which is developed in a box, is considered as a replacement for trees. We talk about trees as a solution for climate change, to reduce the carbon dioxide level in our air. But same thing can be achieved by this particular box instead of planting the trees. Okay, so it's a system that will mimic the trees at the input-output level. It will take in the carbon dioxide, release the oxygen outside, but it's not a tree. It will not do many other things that trees do. It will do the exact same thing that we want. So when we talk about anything artificial, we should be clear about what is it that we expect it to do. Do we expect it to follow the logic, the working of the natural system, or do we expect it to follow just the input-output mapping of the natural systems? Okay. And the last part in the title is about the education. Okay. This is an academic institute, and education is what we deal with every day. So education is about getting certain skills, training people. But which skills are important depends on the requirements of the society. Okay? So perhaps 200 years ago, skills that were important, they might not be that important. 200 years ago, our society was primarily based on agriculture, and we would expect a large part of our society to be well trained in agriculture. Now in 2026, a large part of our society deals with science, deals with finance, deals with technology, and we expect a large part of our society to have skills in those domains. So required skills, they change with time. Okay. So putting all those things together. Okay. So what we want to do. Okay. We want to reverse engineer AI. Okay. So we want to look at the AI systems that work. Once we look at them, we want to reverse engineer them. We want to look at them and understand why this. We need to build the educational programs that help people to build those AI skills. Okay. So that's the agenda for reverse engineering the AI systems for education purpose. Okay. So any questions, any doubts till this point? Or everybody is sleeping quietly? Okay. Let's move. Okay. So if you look around, there are many working AI systems all around. I think every one of us is carrying a mobile phone in their pocket. And I'm sure it has at least a few AI apps already installed. You might have ChatGPT, you might have Gemini, you might have Microsoft Copilot, you might have multiple image generation systems. So we don't have to look further for AI systems that are successful, that are working. But beyond personal use, AI systems are deployed even for things that are far more critical, okay, such as healthcare. Okay. So if you are following the news, just last week, AIMS has announced a clinical decision support system that will be installed across thousands of government. You might be generating images using these AI tools, or you might be generating videos using these AI tools. And your typical description is a text where you describe how you want the image or how you want the video, and output is image or video. So what we have to understand is how exactly this bridging happens, converting your text to numbers, then all the processing in terms of the numbers inside the AI system. And once it comes up with its output in terms of number, converting that number again to the image or video. Okay. So we have to understand how this translation happens. Okay. So again, if you go little in the history before 2010, we were not that great in representing text, images in terms of the numerical format. We did not have methods that would capture the essence, capture the meaning of this data and convert them to numbers. For example, if I take word good and word nice, if I compare their spellings, the spellings are quite different. But if I look at their meaning, the meaning of word good and meaning of word nice is quite similar. So when I convert these words to numbers, what should happen is that the representation should be quite similar. Okay? Similarly, if I take image of a car, which is of, say, green color, and an image of another car, which is of, say, black color, if I just compare their images, the images would be quite different in terms of the color. The cars might have different shape, okay? But finally, both of them are cars. So when I convert both of these images to number, to a representation, they should be similar, okay? And this was the crucial part that we could achieve in last 15 years. We could convert any type of data to the numerical representation while understanding its essence, while understanding its semantics, while understanding its meaning, okay? Once that we could achieve, we could make rapid progress in the AI, okay? Because this is a session with quite limited time and diverse audience, I would avoid going into the details of how do we convert any type of data to the numeric representation. But I see there are many engineering students around here. You should definitely go through such methods and understand them in detail to understand how exactly data of any modality goes as input to the AI systems. And from those AI systems, how do we get the data of any modality? Fine. So inspiration for the AI is, of course, the human brain. So if you look at the human brains, these are some of the important facts about the human brain. Our human brain consists of something called neurons. And a typical human brain has about 10 power 11 neurons, which is roughly around 100 billion neurons. Okay? So you can think about neurons as a sort of processing units that take signal as the input. And these neurons are connected to each other. And each neuron has about 10 power 4 connections, which means that each neuron is connected to about 10,000 other neurons. So now try to imagine our brain, which looks quite small physically. Inside that, we have about 100 billion processing units. And each processing unit is connected to about 10,000 other units. So it's a large network that we have in our brain. Okay? And each of these units can switch on and switch off. You can roughly think about it as output being 1 or output being 0. So whenever output changes from 1 to 0 or 0 to 1, we say that the neuron has switched. Okay? How much time does it take for a neuron to switch its state from 0 to 1 or 1 to 0? It's about 10 power 3 seconds, which is about a millisecond. Okay? So any neuron can change its state in about 1 millisecond. So you take a second and divide it into 1,000 parts. That's the millisecond that we are talking about. So that slow change happens. And whenever we typically see anything and we have to take a decision, for example, if I see face of a person and I have to take a guess about what might be the age of this person, what might be the gender of this person, or what might be the emotions of this person, if I have to make such judgments, what is the typical time required by humans to take such decisions? It is about 10 power minus 1 seconds, which is 1/10 of a second. Okay? So each neuron takes about 10 power minus 3 time to switch on or off, and the final result comes out in about 10 power minus 1 seconds. It means that typically we get 100 steps, 10 power 2 steps to do any task. Okay? It's a very small number of steps that our brain takes, okay? Only about 100 steps, which means that there must be a lot of parallel processing that is happening in our brain. It's not only one sequential program, one sequential code that runs through our brain. The processing happens in parallel in multiple places, but a total 100 steps in terms of time that we get. And we get the answer. And then there is distributed representation of various things, which means that if we compare our brain with the hard disks that we use in our computers, on our hard disk, we can locate specific area where certain thing is stored. Okay? So we have files, images, videos in various folders. You can always open your hard disk and point out one specific physical part of the hard disk where your data is stored. Sometimes you get bad sectors in your hard disk and certain part of data is lost, right? So our hard disk doesn't have distributed representation. It has representation which is a specific, okay? Compared to that, human brain has a distributed representation, which means that a certain concept, a certain thing is represented multiple times in different locations in a distributed manner. And whenever we do things, there is no explicit coding algorithm, okay? For example, if you go and look at simple programming problems that we deal with, for example, if I want to sort the numbers, there are specific algorithms for that, right? You can go and pick up the smallest number first, then the second smallest, third smallest, and so on. Okay, that is one way to sort the numbers. And you can go and list maybe 10 other such algorithms that will sort the numbers in the ascending order or descending order. Which means that whenever we write computer programs, there is a predefined way of solving the problem. Compared to that, if we look at our brain, there is no such predefined algorithm. The way you do a certain work and I do the same work, the logic might be quite different. Even forget about across the person, when we do the same work at different times, we might use different algorithm. So most of the times we cannot tell how we do certain thing. If you look at a person and you guess the age of the person, can you tell me exact step-by-step algorithm? We cannot tell. We might tell the clues that we pick up, is the person's face wrinkled or not, and so on. So you can go on picking up the clues, but we cannot tell the exact step-by-step algorithm. So those are the peculiarities of the human brain. Okay, and all this happens with extremely low power consumption. The amount of power consumed by human brain is about 20 watt, which is almost same as the typical light bulb that we put in our house. Okay, so the single light bulb that you would put in your room, the amount of power that it consumes, approximately same amount of power is consumed by our human brain, and that's the brain that has done all the creative things that we see around, including development of AI. Okay, so this brain is the inspiration for developing the artificial intelligence. This is the natural intelligence that we have. Okay, so compared to that, let's see where our current AI sits. Okay, so current AI has about 10 power 9 neurons, which is about 1 billion neurons. So I'm talking about the models which are the frontier models, the most recent models. Okay, so we have about 10 power 9 neurons. So compared to human brains, we are about 2 orders of magnitudes away. So human brain has 10 power 11. AI currently has about 10 power 9. Okay, and we have about 10 power 3 connections. Compared to that, the human brain has about 10 power 4 connections, which means that we have about 1 order of magnitude less, 1/10 of the connections per neuron. So the physical hardware on which this AI models are run, it operates quite fast. Okay, you might have heard about the frequency at which your CPU works. It is typically in gigahertz, which means that things change at the scale of nanoseconds. Okay, so that's why the switching time of the neurons is 10 power 9, which is a nanosecond. Compared to that, human neuron takes about 10 power minus 3. Okay, so our artificial neurons are quite faster. How much faster? They are million times faster than the natural neurons. Okay, and with that, it is able to achieve quite faster decision time. Human brain typically takes 10 power minus 1 time to decide anything, whereas the current AI models would be able to give you answer in milliseconds, which is 10 power minus 3, which is about 100 times faster. Okay, and just like human brain, current AI models, they have distributed representation, which means that it has the knowledge, it has the training, but you cannot pinpoint which part of the network, which part of the AI model has which knowledge. Okay, it might have read about Shakespeare, it might have read about Einstein, it might have read about Vedas, it might have read about all the news. But if you take a very large neural network, you cannot point a part of the network and say that, oh, this is where the science knowledge is, this is where the finance knowledge is. Okay, it's a distributed representation. And all these neurons, they work in parallel. So just like the human brain, we do have parallel processing. And just like the human brain, there is no explicit coding algorithm to solve any task. So when you give input to a neural network, it will do the processing and give you the output. But it's very hard to go back and say how it generated that output. And that's one of the very interesting research problems to pursue. Can we explain how an AI model generated its output? Okay, there are the efforts that are people putting in, but we are nowhere close to a conclusive answer about how AI models produce their output. However, compared to the human brain, just look at the amount of typical power that is consumed by these AI models. It looks like 20 watt, but there is one capital M before watt, which is 20 million watt. Okay, so compared to a human brain, the amount of power required for current AI models is extremely high. It is million times more than a human brain. So our current AI models are nowhere close to human brain in terms of the power efficiency, and that's a huge bottleneck. Okay, that's why we require huge data centers to run our AI models. We require large amount of water for cooling. We require huge infrastructure to run these AI models. Compared to that, we can just carry our brain on our shoulders and walk around without worrying much. Okay? So that's the difference between the current AI models versus the human brain. Okay? So let's try to open up this black box and understand how these models work. So these models, the current models, they use artificial neural networks, which means that we are going to have neurons which model the neurons in our brain. We are going to have connections which model the connections in our brain. And then we are going to have processing that again is a model of the way brain functions. Okay? And whenever we talk about modeling, we inevitably introduce the error. Okay? So there is a very famous quote by a statistician, Professor Box. It says that all models are wrong, some models are useful. Okay? So whenever you create model of anything, you are going to be wrong. You cannot have a model that is able to 100% replicate the original system. You will introduce errors, but the model turns out to be useful. Okay? If you want example, one of the example is you might have solved the problem of projectile motion in your 11th and 12th. The engineering students, you remember projectile motion? You throw the ball at a certain angle, and then you ask at what distance it will fall down, after how much time it will fall down, to what height it will go. Okay? And while solving such a problem, you create a very simple model of the Earth and everything. You say that Earth is the only entity that is exerting the force of gravity. You assume that there is no friction from air. You assume that the force of gravity is constant, and so on. So when you model this system, you assume the ball to be a particle, and so on. Okay? So the model that we build is a wrong model, but the model turns out to be useful because the answer that you get from such a model has error, but the error is minuscule. With that minuscule error, you can get many useful things done. Okay? And same thing is true about the artificial neural networks. So current model that we have, is it exact replica of the human brain? It's not at all. Okay? But is it useful? It's quite useful. Okay? So a typical AI model would have a large number of neurons as processing units. So if I have to draw it quickly for you, if I have to visualize this, okay. So I can visualize these neurons as the processing units, and there are billions of them, and they are arranged in various layers. So layer after layer. So this is one particular layer, followed by another layer, and there are these multiple units which are there. Typical AI models that we look at today would have hundreds of such layers, and these neurons are connected to the neurons in the next layers and the neurons in the next layers. Okay? And you would have large number of connections between them. And typically your data would flow from the initial layer to the next layer, to the next layer, and finally the output. That's the very simple view of internals of the AI models. So number of such units we have is about 10 power 9, and number of such connections we have is about 10 power 12. Okay? And these connections, they play a crucial role in building our networks, because each of these connection has a weight which tells us what is the importance of each of the connection. Okay? So whenever this neuron, it receives input from all the previous neurons, out of these, which inputs are important and which inputs are not important. Okay? That is decided by the weight of the connection, the importance of the connection. And whenever we talk about training the AI models, you might have heard this thing, right? We want to train the model. We want model to learn. We are talking about understanding the importance of these connections. Okay? So training the AI models is all about understanding which connections are important and which connections are not important. Okay? That's all that AI training is about. Okay? So let's get back. So if you want to understand the internals of AI model, there are neurons, there are connections, there are layers, and all the connections have different weights indicating the importance of those connections. Okay? And now what we have to do is we have to train this AI system. So when you start with a new model, when you say that I'm going to build a new AI model for certain thing, you have no clue about which connections are important, which connections are not important. And it's not one or two connections that we are talking about. We are talking about trillions of connections, because there are about 10 power 12 connections that we are talking about. There are 10 power 9 neurons, and each neuron is connected to 10 power 3 other neurons. You multiply them, you get 10 power 12, which is about a trillion. So think about this system. We have a system where you have to guess the value of 10 power 12 different variables. And how are you going to do it? Okay. Think about solving a simple simultaneous equation that you might have done in your high school maths, right? If 2x plus y is equal to 7 and 3x plus 7y is equal to 9, what is the value of x? What is the value of y? That's the kind of simultaneous equations you might have dealt with. Now think about a system that has not two variables, but a system that has 1 trillion variables, okay? x1, x2, x3, x4 up to x trillion. A system that has 1 trillion variables, and you don't know the value of any of those variables. And you have to guess the value of all those trillion variables. Does it sound like an easy problem to do? Does it sound like a problem that you would like to solve? Well, if you're ambitious enough, you would like to solve, okay? And you might know a very simple thumb rule from your basic mathematics. If you want to solve a system of two variables, how many equations you require? You require two equations. If I just say that 2x plus y is equal to 5, and what is the value of x and what is the value of y, you cannot give one concrete answer. There are infinite possible answers. But the moment I give you two equations in two variables, you can give me one specific solution. So if I have to find out the answer for a system of 1 trillion variable, how many equations I would need? I would need trillion equations, okay? Which means that I would require a trillion data points as well. And typically, you won't find anywhere data that is that big enough and that is available to you. And even if that was available, the processing might not be realistic. So typically, the number of data points that are available to you are far less than the number of parameters that you have. So now we are in a tricky situation. We want to guess the value of 1 trillion variables, but the number of equations we have is going to be far less than that. Which means that, are we going to have one specific solution? We cannot. Okay? And that's why if you train your model multiple times, you might end up with multiple different values of these variables. And that's why you might have models that are different if you train multiple times. Okay? Again, because we are not going into technical details, I would avoid going into details of how we exactly guess these values. But typically what you do is you take one data point, you give it as input to your network. So if you have data point, let's say D1, you pass it through your network and it will generate output, let's say O1. While doing that, it will interact with every neuron in your network. It will also interact with every connection in your network. And based on this interaction, you can create one particular equation that tells you that if I give this input, I receive this output. With one data point, you can create one equation. Fine? And with each data point, you will create a new equation. And you will have billions of such equations if your data has billions of data points. And now you are trying to solve this system of linear equation, not linear, but system of simultaneous equations. Okay? And while doing that, what you want is, you want that the model should faithfully predict the output. If input is D1 and output is supposed to be O1, initially output will not be O1 because you don't know the right values of the connections. So your output will be wildly different. And that's how you measure the error. What was the expected output and what is the output that my system is generating. And what you want is, whenever you train your system over a long period of time, the error should reduce. Okay? And there are mathematical methods available to do that. Okay? So that's how you train your data. And now you understand the importance of data. You might have heard a lot about, oh, data is important, data is critical, the company wants my personal data, this and that. You might have heard a lot about data. Okay? The data is important because data is required to train the model. Each data point becomes an equation to guess the values of these connections, guess the values of the parameters of this AI model. So more data you have, you will have more number of equations. More number of equations you will have more certainty, more surety in guessing the values of these parameters, and your model would be better. And that's why companies like Google, Meta, and many other, they would be more than happy, more than willing to give you all the free services. Okay? So you would have Instagram, you would have Facebook, you would have X and whatnot. Okay? Google search, Gemini, all of them would come begging to you that, oh, this is free, this is cool, please use it, no limit, do all this. Okay? Why is it happening? Because the more you interact with these systems, more data you generate. More data you generate, the same data can be used for training the models. Okay? So if you have to take home any message, especially the school students and the college students here, if you are not paying for it, then you are the product. Okay? So think about any product that you use on your mobile phone, on your laptop. Ask the question, are you paying for it? If you're not paying for it, remember, nobody is sitting there to give things for free to you. Okay? If you're getting something for free, if you're getting Instagram for free, if you're getting Facebook for free, there is something that you're giving in return. And what you're giving is the data. Data about your behavior, data about your preferences, data about your whole life. Okay? So that's why data is the new oil. Okay? The next thing that you might want to know is, if I can give data and AI model can learn from it, what all different things it can learn. Okay? I want to keep some time for the question answer, so I'll quickly wrap up, otherwise you won't have any time for question answering. So a task where output can be verified quickly, those are the tasks where the AI models would excel. Okay? So again, if the input is D1 and output is supposed to be O1, can I verify it if the output is O1 or not? Think about all the domains where this can be done. Okay? For example, coding. If I give the description of the program that I want, if I just write a simple text, I want the program that sorts the number in ascending order, and the AI model generates a Python code for me. Can I verify if that code is correct or not? I can do it quite easily. I can give different inputs and see if it generates the sorted output or not. So all the domains where output can be quickly verified, the AI systems are making quite quick progress. Okay? So just like coding, it can be done in maths. In arts, AI models have made tremendous progress in the last few years in generating images, in generating audio and video. But the question you might ask is how you are going to verify. If I say that, oh, please generate me an image of, say, banyan tree, how good or bad that image is, it's difficult to verify. And that's where you require the human feedback. Okay? So in last one and a half year, there are large number of jobs that have come up which are about the AI trainer, where these companies are recruiting the domain experts from arts, from finance, from biology, from whatnot, from every domain. Okay? And the job of these experts is to give feedback to AI systems, whether the output is right or wrong, is it good or bad, and what improvements are required. And this is drastically different from the old crowdsourcing model that you might have heard of. Okay? If you go 5 years back in the history, the word crowdsourcing was used about a very cheap labeling done by the humans for the computing systems, where you don't require expert. You just require somebody who sits and does the labeling of the data at a very low rate of returns. But compared to that, now AI systems, they recruit extremely proficient people in their domain, pay them very high amount of money, but what they want is the verification of the output. Because once these AI systems excel that domain, there are many potential commercial possibilities. And same thing is happening in the physical world. Okay? Especially in last few months, you might have heard about a new kind of companies where you go and you're not supposed to sit in front of computer or write code, where you're supposed to go and you're supposed to fold the towel, and you're supposed to go there and wash the utensils. You're supposed to go there and just keep the things in the right place. Okay? What happens is that when you do these physical activities, they are recorded with various cameras and sensors, and this becomes training data for the physical AI models which are deployed inside the robots. which are coming in next few months to help you physically. Okay, already there are such robots are out there, but again they required a lot of physical training data, how to navigate the three-dimensional world. Okay, so with text or images you can tell only what to do internally, but to navigate the physical world of three-dimensional, you need the physical data. Okay, so anything that can be verified can be mastered. So if you're thinking about whether AI can do this, ask the simple question: can it be verified? Okay. So the AI revolution is a bit different. I see sometimes people giving the logic of calculators that, oh, the calculators came, but things did not change much. But this is a little bit different. Okay. If you go back a couple of centuries, we had the Industrial Revolution, and what it did was it replaced the human physical effort, right? The machines that we developed a couple of centuries ago, they could do the same physical work that a human was doing, but they could do it perfectly. Okay, and with that, what happened was that what is your physical capability? That was not the main thing in deciding how much you can succeed in the world. Okay, the physical capability was taken out of the question. Okay, then came the computing revolution in the 20th century, and what it did was it replaced the bookkeeping operations. Actually, the word computer, the way it was used in the first decade of the 20th century, 1905, 1907, if you look at actually the job postings for a computer, it was meant for humans. Okay, so at that time, companies that were designing aircrafts, they had to do many detailed computations, and they would actually recruit humans who would do all these calculations by hand on paper. Okay, so in the early 20th century, a computer was a person doing all the calculations manually by hand. Okay, but what happened with computers was that we could replace these hand calculations faithfully using the machinery. But this is a deterministic translation. If you build a calculator that can do addition of numbers, multiplication of numbers, it is a deterministic machine. Okay, if it gives you answer 2 plus 2 equal to 4 today, it will give the same answer tomorrow. It will give the same answer after 10 days, 15 days, or 10 years. Okay, compared to that, AI models are different. AI models are not deterministic. They are probabilistic. So the output that you get now, there is no guarantee that you will get the same output after 5 minutes. There is no guarantee that you will get same output tomorrow. So for the same input, what output you get, there is no guarantee. Okay? And that's the crucial difference between the previous revolutions that we had versus the AI revolution that we have. The machines, the engines that we built 200 years ago, the way that machine operated today versus tomorrow or after 10 years, the machine would operate in the exact same manner faithfully. Okay, calculators operate in exact same manner faithfully. That's not the case with the AI models, and that is something that you should remember. Okay, and because these models are non-deterministic and they can learn anything, they can try to learn anything, they are challenging the human creativity, because there are many people today who think that AI models can perhaps replace or be a cheap replacement for the human creativity. You might have heard about a recent strike by Hollywood scriptwriters, where many of the studios are saying that why we should pay to the scriptwriters for writing the scripts. We can get the script written by an AI model at extremely low money. Okay, and that is something which is open for interpretation. Okay, will AI models be able to replace the human creativity, or they will assist us? Okay, but remember this thing that this is a bit different than what we have seen before. Okay, Geoffrey Hinton, he won the Nobel Prize last year, and in his Nobel Prize acceptance speech, he gave this really interesting observation. He said that we don't yet know how to control or interact safely with beings which are far better or far surpassing the human intellect. Okay, for last multiple millions of years, when humans are on this planet, we were the smartest beings on this planet. There was nothing more smart than us. And in last just couple of years, perhaps, we are building things which might be more capable than us, and we should understand how to manage them, how to interact with them. Okay, that's a whole different skill that we have to get. Okay, one more point is about the ethical use of AI. Again, because there are many students here, and it's in last 1 year, it has become a painful exercise to deal with the copying by students using various AI models. No matter what assignment I will give, they'll come back with the answers generated by the AI models, and I think your experience is the same. So whether something is good or bad really depends on how we use it, okay? There are 3 examples I have given here. Atomic energy, we can use it to generate energy for civilian use. We can make bombs out of it. With rockets, you can build missiles and kill people, or you can use it for space exploration. With internet, you can have fast communication, but at the same time, you can spread rumors, okay? So AI models on their own are neither good or bad. The ethical and safe use is a responsibility of everyone. Okay? And last thing, please don't trust these systems blindly. I see many students coming up with explanation that, oh, this is what the AI model gave me, and that's why I'm doing it. This is what many people I see doing, saying that that's what the AI model says. Don't do that, because these models hallucinate. Remember, whenever AI model is giving you any answer, what it is doing is this simple thing, okay? It takes whatever you give as input, converts it to number, runs it through this large network, which again deals with numbers, generates numbers, and convert it to text or image that you have. Beyond that, there is no explicit thinking happening. It's just the series of computations happening one after the other. With that, if you're getting some output, you should be careful about trusting the output of AI systems. And that's why your expertise in any particular subject, your understanding of any particular subject is important. We cannot simply say that, oh, let AI do it, and I don't care. Okay? And very specific thing about AI models is that they are terrible when you use them for test cases which are out of distribution, which means that these models are trained with certain data, but what you want to do is, if it is quite different than the trained data, then the models won't work well. Okay? You can already see that happening in the image generation AI models. These models are typically trained on the Western data, European, American data. And if you try to generate images which are culturally sensitive for Indian context, these models currently don't do that well. Okay? So that's one obvious way you can see how AI models don't work well. But when you use it for, say, text or other domains, it's a bit difficult to see it. So remember, AI models hallucinate. Okay, and please don't fall for the all doomsday predictions. So I have listed 3. AI will take over all the jobs. AI will destroy society. AI will eliminate humans. All these doomsday predictions, you are the young students. You have the great opportunity to participate in this revolution. You are the ones who can build new models, who can build new applications, who can build new companies, who can solve n number of social problems that we have in our country. Please don't fall for any of these doomsday predictions, okay? It's just a distraction. Put it aside and take up this as one of the things that can be quite useful, okay? So the benefits of AI systems, they far outweigh the potential hazards, okay? Okay, so important lessons that we can have from the previous technologies. For example, atomic capabilities. It was critical for our national security, okay? Today it's a deterrent. It is important for our national security. Same thing about our space program. With that, we could do many things which were previously impossible to do. And same thing about the AI capability. Okay, so the vigor with which we worked with the atomic energy, the vigor with which we worked with our space program, we need the same vigor to work with our AI program and AI capabilities. Okay, and that's where the last point comes in. The students here, if you want to build your career in AI, if you want to take up AI as your endeavor in the future, what does it mean? Okay, saying that, oh, I want to work in AI, it's quite ambiguous thing. Okay, so there are different ways in which you can work in AI. One is to use AI as a tool, as a black box, where you don't really are not concerned about what is the internals of the AI, but you are the end user and you are using it for various things. Okay, so that's where you are using AI as a black box, and that's what the significant part of the population would be doing. Okay, maybe 99% of the population would be the end user of the AI, and that's true for any technology. Okay, take the space technology, atomic energy, any technology. More than 99% of the population is the end user. where they simply integrate that technology in their life. Okay, so that's one way to use the AI, and that is something every one of us will have to do. Okay, just like we integrated electricity in our life, today I don't think anybody here would say that I can live my life without electricity. Even if you don't understand anything about electricity as a science, you know how to use electricity for your personal life. Same thing about AI. But you can go a step further and you can say that, oh, instead of just using it as a tool blindly, I can go and build applications using the AI. Okay, I can build applications for finance domain. I can build applications for the pharma domain. I can build applications for people with physical disabilities. I can build application for people who are economically weaker and so on. So the stage is completely open for you. You can pick up any particular problem, any particular domain, and use AI as a tool to solve the problem and build applications. And some of you might want to go a step further and say that, well, why to think about AI as something only as a tool? Okay, why would I say that I will just use Gemini from Google, I will use ChatGPT from OpenAI? Why to rely on these companies? I will go and build my own AI models, my own AI systems, and then do something with it. Okay, so there is no point in relying on just the external companies. Okay, so some of you might want to go further and actually build your own AI systems, and some of you might think even longer. All these AI models that we use currently, they are based on certain scientific principles. They are based on certain mathematical principles. Can you question them? Can you challenge them? And do a very fundamental research which will bring in a whole new paradigm of AI systems. Okay, so when you say that I want to work in AI, think about it. What is it that you really would like to do? Because for each of these things, different kinds of skills are required and different type of education is required. If we mix them, then it's perhaps not a great idea. So it's good to have clarity. What is it that you would like to do? And then accordingly learn the things. Okay. So that's all from my side. I'll be happy to answer any questions and doubts from the students and all the other attendees.
Good afternoon, sir. I'm Nishanjuti Haloi from North Guwahati College. I have two questions. The first one being that, as we are aware, internet have existed for over 3 decades now, and programming languages are even older than that. But as I've noticed, the major AI boom happened around or after 2021. But the idea was old, which I know. Then what was the constraint that we had that we could not something as powerful as like the nowadays LLMs? That's my first question. What were the constraints? And the second one is that nowadays it's much smarter to use AI instead of some skills. Like for example, writing an email. Writing a catchy email is a skill which I believe, but nowadays it is much easier to use an AI and it gets you a much better result. But do you think that there will ever be a scarcity of such manual skills among people? Because if not, then it sounds kind of a little bit stupid to be even learning such skills if AI is gonna replace that.
Okay.
Those are my questions.
Okay. So answer to your first question, what happens recently such that now we have very capable AI models? Two things happen. One is the hardware that can do things quickly and availability of large amount of data. Okay. So the idea of artificial neural networks was there for decades. Okay. So nothing much new there. Okay. But in last 13, 14 years, what was critical was that we could get GPUs, graphical processing units that could do matrix operations in parallel. Because of that, we could do the training and inference over the AI models quickly. So it was mainly the hardware that sparked this change, and along with that, availability of large amount of data. Okay. And your second question was that if there is certain thing that AI will anyway do, is there any point in learning such a skill? And please, please, please don't fall for this thing that anyway AI will do it, I don't have to do it. So AI can generate computer programs, so I don't have to learn programming. AI can solve maths problems, so I don't have to learn maths. AI can write good emails, so I don't have to learn how to write well. The current catchy email that you said, okay, it's catchy because 100 other emails that you get are not written like that. Only one email is written in that particular way, and that's why it gets your attention. But when everybody starts using the AI tool, all the 100 emails are going to look exactly the same. and you will no more feel it catchy. And you will no more feel it catchy. What will feel catchy? The one who writes in their own distinctive style. Okay? If rest 99 people are going to send email through Gemini, and I think and write my own, my email will catch the attention of the human reader. Okay?
Thank you, sir.
Okay.
Good afternoon, sir. My name is Fariha Firdosh Ahmed, and I'm a student of West Guwahati Commerce Senior Secondary School. My question to you is, as students, we often hear that AI can make healthcare cheaper and make it accessible in backward areas. But this question encourages us to think about whether cost cutting through technology might affect accuracy, safety, and human care. So, how can AI be used in the healthcare to reduce treatment cost without compromising the quality of care?
So this is something people have been predicting many times and they have been wrong. So 2014 or 2015, computer scientists made the prediction that AI is getting so well at analyzing the X-ray images. In few years, we will not need radiologists. In 2026, radiologists are not unemployed. They are doing well. But what has happened is that the AI tools that analyze X-rays, they're helping the radiologists. Okay, so AI tools are getting integrated more and more in our healthcare. With that, what happens is that previously, if a doctor could see 10 patients in 1 hour, with AI tools, now a doctor can see perhaps 15 patients in an hour. So with the existing number of doctors and medical staff, we can deal with more number of patients. Second thing is that previously analyzing the test reports and everything was costly because it required the time of an expert doctor. But now same lab reports and imaging can be reviewed by AI. So it reduces the cost of analyzing those reports. So now more people can go through those tests. With that, you can have more preventive medication. So by integrating these tools, the cost eventually comes down because the same expert can deal with more number of patients in the same amount of time. And about the accuracy and the faithfulness, that is something we have to work on by building systems that are faithful. Okay, so that's an open challenge.
Okay, thank you, sir.
Hello. Yeah. Hi. Good afternoon, Professor Sir. Sir, I'm Laisham Trinity, and I'm from Nelly Imphal. Sir, I have a question. Like, since you are delivering for the AI, and if we dive into the machine learning, and if we go into the reinforcement learning, then shall we say no to the output which is predicted from the reinforcement learning, as there is penalty and the reward system is there? So could you please explain about this? Like, whether should we trust the output which is predicted by the reinforcement learning, or shall we not? Thank you, sir. That's my question.
Reinforcement learning is one of the very useful approaches for training the AI model. So there is no reason why we should discard reinforcement learning. Okay.
Are there any more questions?
Hello, sir. Myself, Tanmay from Guwahati University. Sir, I have my interest in machine learning, and I have seen from IIT Guwahati page that you have also research interest in data mining and machine learning. So I have a basic question regarding machine learning. How do you decided a problem need machine learning, or it can be solved using simple statistical model like logic recursion or KNN itself?
So you have to see the complexity of the problem. And of course, first you apply the simple methods and see where you reach. If you don't get good enough answer, only then you should invest in more complex methods. Okay? So that's the thumb rule you should follow for any problem. See if it can be solved using a simple tool, simple method. If it is not satisfactory, only then go for more complex methods.
Sir, I have a follow-up thing to say. Okay. Sir, I am also doing my BS in data science and machine learning from IIT Madras. So it will be silly to say here, but do you have any internship spot under?
It's for you to have your opinion. But more urgent, important question is how do we make these AI models safe, ethical, responsible, and useful for many, many problems that we have around?
Sir, my next question is, if AI only simulates our emotions rather than truly feeling them, how can it tell the difference?
You're saying, can AI models understand our emotions?
Yes, sir.
So again, when we say that AI models are supposed to understand our emotions, we are creating a model. We are saying that, oh, here are the thousand millions of examples of happy person, angry person, sad person, and based on that, the AI model will have its interpretation. Okay, so is it good enough or not? That is open for interpretation.
Thank you, sir.
Okay, but with time, with more training, AI systems will definitely get better at understanding even the emotional part. Okay, that's for sure.
Thank you, sir.
There will be last questions.
Good morning, sir.
Okay.
I mean, it's good afternoon, sir. I am from KV IIT, and my question is, if AI can generate content and solutions rapidly, how do we preserve originality, critical thinking, and long-term innovation in the workforce?
Uh, so only solution for that is to have good practices while using the AI tools. So children, for example, children who are in primary school, we don't hand over them calculators directly, right? We make them go through the tables, we make them do addition, subtractions by hand, and only after they reach certain age, we give calculators in their hand. Okay, same practice we have to follow. Okay, so while in the primary school or high school, we should not let students generate text directly using AI methods. We should uh, build their writing skills, reading skills, thinking skills. Same thing about other domains like programming and mathematics. We should spend enough time doing these things by hand and only then take the help from the AI models. Okay. Without that, we will atrophy our skills. Okay.
Okay, thank you so much, sir.
Okay.
So this will be our final question.
Good afternoon, respected sir. Sir, my name is Parthapratim Saloy. Sir, I'm from Praxis College, Guwahati University. Sir, my question is, sir, what is the biggest illusion people have about AI today, and what is the reality? Like, as we all know that AI works on predictive modeling, but we are treating AI like it is like human, like okay, like we treat that as we type a prompt, it gives output. Then again we give it a prompt again that humanize it. So why we don't understand it not a human and but a machine that created by human. So like what's the biggest risk? Like my take is that the biggest risk is not that AI is becoming human-like, but we are treating the AI that it is already is a human. So, like, what's your like? Can you throw some light on it? What's your perspective?
And my opinion is that one of the illusion which is given by all these companies who have invested heavily in their products is that, oh, it's the AGI or ASI just around the corner and it is ready to replace the humans. It can do everything on its own. Okay, so they have to create that hype because they have invested so much money and their commercial success depends on it. But we as users, we as common people, we don't have to believe that. There is a lot of room to improve these systems and there is a lot of room for the human skills and expertise. So we should not get worried. We should not stop learning the things. We should look at these as useful tools that are imperfect and carry on with our life. Okay? Think about AI as one more technology in our life.
Thank you, sir.
Thank you, sir. We will closing this session.
Okay, thank you.
We will go for lunch.
Yeah, sure. Yeah, sure.
Thank you, sir. I request Professor Sukanta Bhattacharjee to kindly felicitate the speaker. To conclude this event, I request Professor Ranbir Singh to kindly come on the stage and share the closing remarks.
Okay. All is well? Okay, sorry. Like all the things, we always have ending. So with heavy heart, with after 1.5 days of exciting session, so this is we came to the end of this event. And again, this event is part of the big vision from our Honorable Prime Minister Shri Narendra Modi ji to make India as a global power, right? So we extend on behalf of the organizing committee, Government of Assam and IIT Guwahati and all the participants on your behalf also, I am extending gratitude to our Honorable Prime Minister. And I cannot conclude this session without mentioning few of the special key person who has played major role in making this event successful. And we have these wonderful sessions and big display, good food, then your travel, all the arrangement, it needs money, right? So I also first, before mentioning the key person driving this event to this stage, I also first want to kind of thank India AI, Ministry of Information Technology, and the team from India AI for arranging all the events minutely planned and making it well success. Big round applause for India AI team for sponsoring this event. And all this idea and this action is under the directives of Sir Sri Abhishek Singh, Additional Secretary MeitY, DG NIC, CEO India AI. So under his instruction, every activities is executed with minute details and perfection. So we extend our sincere gratitude to Sir Abhishek ji. And Sir Sanjay Sanjay Kumar Vyas, Senior Scientist Officer on Special Duty to Secretary at the Ministry of Information, Electronics and Information Technology. In spite of his busy schedule, he visited us, attended all the sessions yesterday, and first half of the session. So we also extend our sincere thanks to Sanjay sir. Then, without the support of Sri Gopinath Narayan sir, IAAS, Principal Scientist, IT, Government of Assam, and Sri Ashwini Kumar ji, IAS Director, DTech, Government of Assam. Without their support and minute guidance, support and guidance, this event would not have been possible. So I also extend on part of our IIT team. So as to our another organizing team. So sir, thank you, sir, for making it successful. So lastly, this event is part of the India AI Summit under the Human Capacity Working Group, which is chaired by Professor T.J. Sitaram, Sir Chairman, Human Capital Working Group from our IIT Guwahati. So we also extend our gratitude to him as well. Then all the team members from MEA, India AI, NEDG, and other delegates from Government of India. And most importantly, this event cannot be successful without the participants. So we also extend our appreciation and gratitude to all the students, faculty, and the parents for believing us and sending you here to attend this program. And without your participation, this event will not be successful. So we also thank you very much for attending this session and making it successful. But I want to mention Dr. Hemant Rava sir. I think he might be in the audience. Okay, sir is sitting in the last. So I think because of him, I think we are able to connect with all of you. So, sir, special thank you, sir, for your support and all the meticulous planning for say connecting to schools and bringing all the students here. So we also extend our sincere gratitude to Professor Devendra Jalihal, Director IIT Guwahati. So with his supervision and all the supports, this event could have been happen. Along with him, all the administrative team, IIT Guwahati different department sections, and all the supporting staffs for making this grand success. Further, I also want to extend my sincere gratitude to all my colleagues and volunteers for tirelessly making it successful. You may know that these major activities of this event happened in last couple of days, and all of them have put up full effort day and night, and ultimately this is the result that we see today. Thank you, all my colleagues and volunteers. Then, media person for covering this event. We also want to extend our speakers for insightful presentation and the deliberation, keeping all the audience engaged and exciting. We extend our sincere gratitude to all the say speakers, resource persons. Lastly, but not the least, let us thank our volunteers who have worked tirelessly day and night. And I would like to mention that some of the volunteers did not have sleep more than 2 or 3 hours. I know that some of the volunteers sleep 2 o'clock in the morning and had to wake up around 3 o'clock in the morning. So I also do that, but but that is like very unusual thing for them. So let us give a big round of applause to them. And lastly, I owe one apology to all the participants for the issue that we had with the issue with the food that we had yesterday. In spite of all our instructions to the vendor, things has happened. So one of the item was, I think, had some problem. So from the organizing side, we don't have any. We have taken all possible cares. In spite of that, because of the negligence from the suppliers, it has happened. So I really apologize for this to all the participants for that issue. And I think we have given a strict warning, and it does not repeat today. So with this, I wanted to list out all the names of these schools and colleges attended here because that is very important. But when you want to do something, always your negative force will be more. So my mobile was just 1%. So, so I'm afraid that it may incomplete reading this. So though I am not mentioning individual names, so yeah, thank you all the school authorities and college authorities for allowing you to participate here. So yeah, thank you very much. Happy New Year, and let's hope we again get chance to meet you all in another occasion. Thank you very much.
Thank you, sir. We now proceed for networking lunch. There is a small announcement. The delegates and speakers may proceed to the conference center for lunch, and school college participants may proceed to the backside of exhibition stalls like yesterday. And the students are requested to kindly carry their ID cards and move in a queue and coordinate with the volunteers. Thank you.